So first of all, in P1 section, units and dimensions. So in the chapter units and dimensions, okay, so let us do some important questions. So first model I want to cover is principle of homogeneity. Principle of homogeneity. So what is the meaning of principle of homogeneity? Okay, in brief. So for example, C equal to A plus B or A minus B. So here A is a physical quantity, B also a physical quantity, resultant C also a physical quantity. So A, B, C are three physical quantities. And what is the meaning of principle of homogeneity means in the case of addition or subtraction. So what are the two quantities A and B? They should be having same dimensions or different dimensions. In the case of addition or subtraction, dimensional formula of the physical quantity A and dimensional formula of the physical quantity B, they should be having same dimensions. In the case of addition or subtraction, A and B should be having same dimensions. If A and B should be having same dimensions, then resultant C also same dimensions. Resultant C also having same dimensions. Now it is the principle of homogeneity. In the case of addition or subtraction, the given two quantities, the given two quantities A and B, a resultant quantity C. So all three have same dimensional formula. Okay. So in brief, it is about principle of homogeneity. So let us write down the question. Okay, note on the question. So in the question, potential energy is given U equal to A root over X upon X square plus B. And we have to find dimensional formula of A into B. So we have to find dimensional formula of A into B. Okay. So in the question, we have given potential energy equation is given. So U equal to A root over X upon X square plus B. So first of all here, if we observe denominator, in denominator we have addition is present. If addition is present means over here we can apply principle of homogeneity. So according to principle of homogeneity, B dimensional formula, X square dimensional formula, this resultant X square plus B dimensional formula will be same. So first of all, you apply homogeneity principle in denominator. So then what we get, dimensional formula of B, dimensional formula of X square, and dimensional formula of the resultant B plus X square, they have same dimensional formula. Okay, so therefore I'm taking dimensions on both sides. So dimensions of U equal to dimensions of A into dimensions of root over X. So in the whole, dimensions of X square plus B. Now we have to take dimensions on both sides. So any one of you please answer, what is the potential energy dimensional formula is? Potential energy M L square T minus 2 equal to, so numerator dimensional formula of A into X means distance. So distance means L dimensional formula. So L power 1 by 2. So it is L power 1 by 2 upon, already we have according to homogeneity principle, X square plus B dimensional formula, that is equal to B. So in the place of dimensional formula of X square plus B, I am writing dimensional formula of B. So it is nothing but dimensional formula of. So, but we have to find dimensional formula of A into B. Dimensional formula of A into B, and here we have dimensional formula of A upon B we have. So dimensional formula of A upon B we have, but we have to find dimensional formula of A into B. So regarding that, what I'm doing is, let us multiply with dimensional formula of B and divide with dimensional formula of B. Then if we simplify it, left side m L square T minus 2 equal to, so over here we have L power 1 by 2. See numerator, dimensional formula of A into B we have. So it is dimensional formula of A, dimensional formula of B, so dimensional formula of A into B. Then after in denominator, so what is the dimensional formula of B? Dimensional formula of B is nothing but x square dimensional formula. Dimensional formula of B is nothing but x square dimensional formula. So what about x square dimensional formula is L square. Okay, so this B dimensional formula is L square. In the same way, this B dimensional formula also L square. So therefore, if we do simplification, so we can find out dimensional formula of A into B. Okay, so you do simplification later on. So this is the procedure we have to follow according to homogeneity principle. So wherever plus or minus is present, so this type of questions solving by homogeneity principle is much easier. Okay, in denominator we have plus is present, so you apply homogeneity principle over here. Okay, is the question clear?
Yes, sir.
Yes, sir. Yes, sir.
Okay, so the same model, let us try one more question, then we go for next model. Okay, see the question. So here P means a pressure. P means a pressure equal to A minus T square upon B into X. So X means a distance and T means a time. We have to find A upon B dimensional formula. Okay, A upon B. So A upon B dimensional formula we have to find out. Okay, so the given question is pressure equal to A minus T square upon B into X. In the numerator we have subtraction present, so we can follow homogeneity principle in the numerator. So according to homogeneity principle, dimensional formula of A, dimensional formula of T square, dimensional formula of A minus T square, all three are having same dimensional formula. It is according to homogeneity principle. Okay, A dimensional formula, T square dimensional formula, A minus T square dimensional formula will be same, and that is equal to capital T square, because we have T means time. Okay, so capital T square. Now listen. So in this equation, let us take dimensions on both sides. So dimensions of pressure equal to dimensions of A minus T square upon dimensions of B into dimensions of X. So we are taking dimensions on both sides. And what is the pressure dimensional formula is M L minus 1 T minus 2. Okay, pressure dimensional formula. In the numerator, in the place of dimensions of A minus T square, in the place of dimensions of A minus T square, we can write dimensions of A. Okay, in the place of dimensions of A minus T square, we can write dimensions of A. So numerator value dimensions of A upon in denominator dimensions of B into dimensions of X, that is L, because X means the distance is given. So distance dimensional formula L. You bring L to left side. Therefore, what we left with here? Therefore, dimensions of A upon B equal to, you bring L value to left side and simplify, we have the answer. So I'm keeping this question as empty and I will share the notes in the group. Okay. So you please try to complete this question as a homework. Okay, same type of model. Okay, this question you try as a homework. We have to find dimensions of A into B. Okay. Then after, one more question. Same, this question also homework. So equation is given. We have to find A into B dimensional formula. See, denominator plus is given in denominator. So plus is present means here. So over here, we can apply homogeneity principle. Okay. So this question also you try as a homework. So is the model clear? Do you have any doubts in this model?
No, sir.
Okay. Okay, so you please try to complete this question. So let us try to complete this question. So in this question, y equal to a sine omega t plus bt plus ct square cos omega t, we have to find dimensions of a into b into c. Okay, dimensions of a into b into c. So just to go through the question, if you can try, you will do it. Otherwise, I will do this question. That's up to you. Go through the question. If you feel comfortable, then you can solve it. So for example, in the case of trigonometry function, no, it is trigonometry function. So in the case of trigonometry function, they don't have any units and dimensions. It is a trigonometry function, no units, no dimensions. Then after, it is also trigonometry function, no units, no dimensions. Therefore, on both sides, we have dimensions of y equal to dimensions of a plus dimensions of b into t plus dimensions of c into t square. So only these terms are having dimensions on both sides. So y having dimensions, a having dimensions, bt having dimensions, ct square having dimensions. Okay, so here if we apply homogeneity principle, so we have plus is present. So here also plus is present. If we apply homogeneity principle, all these are having same dimensions. Okay, that means here dimensions of y, dimensions of a, dimensions of bt, dimensions of ct square. According to homogeneity principle, all these are having same dimensions. Okay, so first of all here, so what is the meaning of y? So given that y equal to a sine omega t, something is given. So you please answer. So in this case, we have to find dimensions of a into b into c. So first of all, dimension of a, that is equal to dimension of y. One thing is completed. Then after, I'm equating these two terms. We are equating these two terms. So from these two terms, what is the dimension of b equal to? Dimension of b equal to dimension of y into t or y upon t?
I upon T.
Y upon t. Dimension of y upon t. Then after, you equate these two terms. So then dimension of c equal to what we get? Dimension of y upon
T
t
square.
square. Therefore, you multiply y because we have to find dimensions of a into b into c. So if we multiply y into y upon t into y upon t square, so therefore what we get? Y upon t to the whole cube. So it is a final equation. Okay, so the method is very simple. We have to follow homogeneity principle. That's it. Okay. So it is the first model, homogeneity principle. So let us try the second model in units and dimensions.
So can you show the last part thoda upar? Thank you.
Will you be sending all these notes?
Sure, definitely. So this is the question. In second model, so alpha upon t square equal to f into v plus beta upon x square. So t means the time, f means force, v means velocity, and x means distance. And we have to find alpha dimensional formula. We have to find beta dimensional formula. Okay, same thing. This also homogeneity principle we have to follow. So over here we have addition is present. So addition is present means simply dimensional formula of alpha upon t square, dimensional formula of force into velocity, dimensional formula of beta upon x square. So all three are having same dimensions. So you please answer, for example, if by equating these two equations, so can we find out alpha dimensional formula or not? Because we know force dimensional formula, we know velocity dimensional formula, and we know time dimensional formula. By simplifying, we can find out alpha dimensional formula. Okay. So in brief, it is a procedure. In the same way, by equating these two terms, by equating these two terms, we know force dimensional formula, velocity dimensional formula, that multiplication, and x means distance, we know distance dimensional formula. By simplifying, we can find out beta dimensional formula. Okay, so the procedure you try later on. Okay, now this is the method we have to follow. Next, one more question. So before that, you please answer pressure into volume. It is having dimensions of P into V. Dimensions of work done, correct? So P into V, nothing but nRT. So nRT also having dimensions of work done or dimensions of energy. Okay, so pressure into volume is having dimensions of work. In the same way, nRT also having dimensions of work. Now in this question, so pressure equal to something is given and we have to find dimensional formula of A. So it is A, and dimensional formula of B. So both A and B dimensional formula we have to find out. So B dimensional formula is very, very simple. Why? Because over here, so we can apply homogeneity principle over here. So if we apply homogeneity principle, now what we can say, dimensional formula of V volume, dimensional formula of B, and dimensional formula of V minus B. All these three are having same dimensional formula. The dimensional formula is L cube because volume. So volume meter cube, so length cube. So therefore B dimensional formula. So B dimensional formula is L cube. Then after, next we have to find dimensional formula of A. Regarding that, you focus on this term, this exponential term. We know exponential is unitless, dimensionless. Okay, exponential, logarithm function, trigonometry function. Okay, these are the unitless and dimensionless function. So it is exponential means dimensionless. Okay, it is a dimensionless means A upon R T V also dimensionless. Okay, that means M0, L0, T0 dimensionless. If exponential function is dimensionless, that means this power also dimensionless. Dimensionless means M0, L0, T0. Now we are finding a dimensional formula. So from this equation, so we are finding dimensional formula of A upon, so here you focus RT dimensional formula is nothing but a work. So n equal to 1 mole. Okay, maybe they have taken n equal to 1 mole. So what about RT dimensional formula is a work. Okay, so in the place of R into T, we can write work dimensional formula, and V means volume, and we know volume dimensional formula. By simplifying, we can find out A dimensional formula. Is it clear, this method? We know RT dimensional formula, okay? And we know volume dimensional formula equal to, on right hand side, it is equal to 1. It is equal to 1. So you write down RT dimensional formula, means work done dimensional formula, and V means volume dimensional formula. By simplifying, we can find out A dimensional formula. Okay. So this notes I will share in the group. So later on, you try to complete all the simplifications. Okay, same type of model. So here pressure P means the pressure alpha upon beta e power minus alpha z upon k theta. Okay, so P means the pressure, Z means the distance, and K means Boltzmann constant, and theta means absolute temperature. And we have to find, so alpha dimensional formula, beta dimensional formula. Let us find out both. Okay, alpha, beta, both dimensional formula. Let us find out. Okay, so first of all, you focus on this exponential term. So we know exponential is unitless, dimensionless. Okay, that means alpha z upon k theta also unitless and dimensionless. Dimensionless means m0, l0, t0. Okay, so from this alpha into, in the question, z means distance. Z means distance, and we know distance dimensional formula is L upon K means Boltzmann constant. K means Boltzmann constant. For Boltzmann constant, what is the unit is? So we know the value 1.38 into 10 power minus 23 joule per Kelvin. So you focus on the units. According to units, what is the dimensional formula? Joule means energy or work done. So energy dimensional formula m L square T minus 2. And K means the Kelvin, temperature, a fundamental quantity. So K as it is. K to numerator becomes K minus 1. Okay, this capital K indicates Kelvin, temperature, a fundamental quantity. So therefore, for K Boltzmann constant, so what is the dimensional formula is? It is m L square T minus 2 Kelvin minus 1. Then after theta means temperature. So temperature K Kelvin equal to, on right hand side, equal to 1. So anything power 0, nothing but 1. So if we observe here, one L value cancel out, and K minus 1 K also cancel out. Now after cancellation, see alpha in the numerator. Now in denominator, what we have, M is present, one L value present, next to T minus 2 present, equal to 1. Therefore, alpha equal to, we get M L T minus 2. It is about alpha dimensional formula. And in the same way, we have to find beta dimensional formula. So it is very simple. Now this exponential is, okay, dimensionless quantity. Therefore, on both sides, what we left with pressure, alpha upon beta, pressure, alpha upon beta. So therefore, dimensional formula of pressure equal to dimensional formula of alpha upon dimensional formula of beta. Okay, this we left with. Why? Because it is exponential, so no dimensions. So P dimensional formula equal to alpha dimensional formula upon beta dimensional formula. So P means a pressure, and the pressure means M L minus 1 T minus 2 equal to, so alpha dimensional formula. So we have already alpha dimensional formula. So in the numerator, I'm writing M L T minus 2 upon, in denominator, dimensional formula of beta. So by simplifying, we can find out beta dimensional formula. So by simplifying, we get dimensional formula of beta, that is equal to L square. So correct option. A is the correct option. So it is second model. So next coming to third model. So in this question, Y means Young's modulus and V means okay, speed of the sound in elastic medium. Rho means density. Now density rho proportional to Y power A and V power B. So we have to find B square upon A. So it is numerical integer type of question. Okay. So here density proportional to Y power A, V power B, and we have to find the value of B square. So B square upon A. Okay, I think sound waves chapter is going on. In solid medium, how to find speed of the sound wave? In solids, how to find the speed of sound wave? V equal to root over Y upon rho. Okay, so why? Because here we know the formula already, so no need to simplify it. Okay, so in simplest way, it is nothing but V square equal to Y upon rho. That implies from this equation, rho equal to we get Y into V power minus 2. Okay, rho equal to Y into V power minus 2. And in the question, it is given that density rho proportional to Y power A and V power B. So by comparison, what is the A value here? So Y power 1 over here and Y power A over here. So by comparison, we get A value is 1 and B value is minus 2. But the question is we have to find B square upon A. So let us find out. B square upon A equal to what is the value? We get 4. Is it clear? Any doubts?
No, sir.
Sir, can you explain the last part again where you took A equals 1 and
See, generally here, it is according to the formula we have, theoretical formula. So Y power 1, okay? But in the question, density rho proportional to Y power A and V power B. So it is given in the question. So do comparison, Y power equating them, A equal to 1 and V power equating them. So by equating them, B value is minus 2. So by equating them, so Y power is A and it is 1. So A equal to 1 and here B equal to minus 2. Okay. So it is the same type of model. So in this question, E means energy. So this energy proportional to time period, okay, power A. Rho means density power B and P means pressure. Okay, so P means pressure power C. Okay, now we have to find A square C upon 5 B square. So E means energy, correct? E means energy. So what is the energy dimensional formula is M L square T minus 2. M L square T minus 2. Proportional to T means a time period. So capital T dimensional formula. Power A. Rho means density. Density dimensional formula M L minus 3 to the power B. And P means the pressure. Pressure dimensional formula M L minus 1 T minus 2 to the power C. So first of all here, do one thing. I'm comparing powers of M on both sides. Left side, what is the power of m1? Left side, power of m1 equal to right side, what is the power of m? Over here b and over here c. Okay, so on right hand side we have b plus c, equation number 1. In the same way, let us equate powers of L on both sides. Left side, what is the power of L2 equal to on right hand side? So what is the L power minus 3b? L power minus 3b, and here L power minus c. L power minus c. So it is equation number 2. Next, by equating powers of t on both sides, left side t power minus 2 equal to on right hand side t power. So over here t power is a, and over here t power is minus 2c. Minus 2c. So therefore we have 3 unknowns. So what are 3 unknowns? We have a, b, c, and we have 3 unknowns and we have 3 equations. So by simplifying 3 equations, we can find out all the 3 unknowns. So that is, you do it. So by simplifying equation 1, equation 2, equation 3, so we can find out the values of a, b, c. If we know the values of a, b, c, the required value we can find out. So what is the value we have to find? So we have to find a square c upon 5b square. So this value we have to find out. So first of all, simplify all the 3 equations, find out a value, b value, c value. After finding a, b, c values, then after, so let us find out finally this expression, a square c upon 5b square. So can you do it, the further simplification?
Yes, sir.
Yes, sir.
So all these are the integer type of questions. Okay. Same here, to find distance d over which a signal can be seen clearly in foggy conditions. Okay, a railway engineer uses dimensional analysis and assuming that distance, okay, distance d, okay, so distance is given d. This distance depends upon mass density. This distance depends upon intensity s, okay, and frequency. So therefore, in the question, it is given distance d depends upon mass density rho power a. Then after, also depends upon intensity. So here intensity is given s. Intensity is given s. So intensity s power b. Then after frequency power c. And we have to find, so distance d proportional to, so distance d proportional to s power b, and we get some b value. This b value is given 1 upon n, and n value we have to find out. Okay, so d means a distance. Distance means what is the dimensional formula is L. Distance means L, dimensional formula. Proportional to rho means mass density. Mass density means mass upon volume. Okay, mass upon volume means what is the dimensional formula? M L minus 3 with a power A, and S means intensity. So S means intensity. Intensity means power upon area. And what is the power dimensional formula is M L square T minus 3 upon area means meter square. So length square. So length square cancel out. Therefore, what is the intensity dimensional formula is M T minus 3. MT minus 3 intensity dimensional formula with a power B. And F means frequency. We know frequency means 1 upon time period. So T minus 1. T minus 1 power C. Same method by equating powers of M on both sides. Equating powers of M on both sides. So left side, no power of M, so 0. On right hand side, what is the power of M A and what is the power of M B? So A plus B. First equation. Next, by equating powers of L on both sides. Left side L power 1, right hand side L power here minus 3a. It is minus 3a. And do we have any more L power? No. Okay, so only we have minus 3a. Okay, so simply by equating them, what we get, a value is minus 1 by 3. If a value minus 1 by 3, so then what is the b value? From this equation, we have b equal to minus a. We have b equal to minus a. So a value minus 1 by 3, we got it. So what is the b value we get? 1 by 3. Okay. So now I want to find only b value. Now in the question, what they have given, so distance d proportional to s power 1 upon n is given in the question. But here what is our assumption? So we have taken distance d proportional to s power b. What we have taken, distance d proportional to s power b. So and what is the b value we have? So distance d proportional to s power, in the place of b we got 1 by 3. So 1 by 3. Simply you compare both equations. Now what is the value of n equal to? 3. So n equal to 3. It is final option. So maximum, as per mains point of view, this third model is very, very important. Okay, so finding a value, b value, c value by the method of dimensions. Okay, so this third model is very, very important. Completed?
Yes, sir.
Okay. Yes. So it is about dimensions. Next, error analysis. Okay, so in brief, in 5 minutes, okay, I will do some important formulas in error analysis. So first formula is, if z equal to x plus y, if z equal to x plus y, what is the maximum percentage error, maximum percentage error in z? What is the formula? Do you know that? Delta x plus delta y upon z value is x plus y into 100%. Okay, so maybe all these points we completed in 11th standard. So you please go through the derivation. Okay, you please refer 11th standard notes. Maybe you will get the derivations. Okay, so if z equal to x plus y, so we are finding maximum percentage error in z value. Okay, so delta x plus delta y. So here z is x plus y. In the same way, if z equal to x minus y, then how to find maximum percentage error in z value?
So same formula.
See, numerator will be same, delta x plus delta y, but denominator is x minus y. Because in the question, this z value, so z value given x minus y. And errors always we have to add. So either it is addition or subtraction. So errors always we have to add. But depending upon z expression, if z equal to x plus y, denominator x plus y. If z equal to x minus y, denominator x minus y. Okay, but errors should be added. So now addition is completed. So derivations are not important. Only the equations are very, very important. These equations.
Or in the second one, into 100 will also come.
Into 100. Okay, in numericals, generally we follow into 100. Okay. Then after, next multiplication. Z equal to x into y. So what we get? Delta z upon z. So same thing, we are finding maximum percentage error. So delta z upon z into 100% equal to what we get? Delta x upon x plus delta y upon y into 100%. Okay. See, in the simplest way, in error analysis, this multiplication converts to addition. Okay. this multiplication converts to addition. So delta x upon x plus delta y upon y into 100%. Fourth one, z equal to x upon y, division. Z equal to x upon y, same thing, we are finding maximum percentage error in the resultant z. So this also equal to delta x upon x plus delta y upon y into 100%. So we are finding maximum percentage error. Okay. See, in the case of multiplication or division, so multiplication converts to addition, so division also converts to addition. So it is a simple logic. So we have to remember like this. Okay, multiplication converts to addition. Even though division is present, it converts to addition. Okay, the formula will be same. Next, fifth one is power. For example, if we have y equal to x power n, if y equal to x power n, now what is the value of delta y upon y equal to n into, first of all, the power we have to write. First power we have to write. So n into delta x upon x. So we have to find in terms of percentage. So here into 100%. Same thing here into 100%. So whatever power is present, the power, so it comes first. So power first we have to write. So n into delta x upon x. Now sixth point. For example, if we have z equal to x power m into y power n. Now I want to find maximum percentage error in z value. Maximum percentage error we are finding. I told you already in error analysis. Okay, so this multiplication converts to addition. Then after you see individual terms. So first individual term x power m. So x power m means write on power first into delta x upon x. Then after you see next individual term, that is y power n. So y power n, write on power first, n into delta y upon y into 100%. Okay, so this multiplication converts to addition. Then after you take individual term. Now this individual term, okay, power function formula. This individual term, this power function formula. Seventh one. For example, if z equal to, we have x power m upon y power n. Same thing, we are finding maximum percentage error in z value. Maximum percentage error. So I told you already, if we have multiplication is present, division is present, in errors, it converts to plus. Okay. So in the place of division, so plus. Then after you take individual term. Okay. So this individual term, you apply power function formula, that is m into delta x upon x. Then after you consider this individual term, what is a power n into delta y upon y into 100%. Okay, so this division converts to addition. Then after you take individual term. Now this individual term accordingly, so we have to write on the formula. Okay, next, z equal to, for example, x power m into y power n upon, for example, I'm taking p power q, for example, anything, p power q. Now I want to find out maximum percentage error in the resultant z. So I told you already, this multiplication converts to addition, and this division, okay, this division also converts to addition. Okay, so this multiplication converts to addition, this division also converts to addition. So therefore we have three individual terms. So first individual term, x power m. X power m is nothing but m into delta x upon x. Next individual term, y power n. So y power n means n into delta y upon y. So next individual term p power q. So first power we have to write. So that is q into delta p upon p. Q into delta p upon p. So for example, in some questions, if y equal to k into x power n, k means constant. Okay, k means a constant value. So if y equal to k into x power n, now what is the value of delta y upon y equal to? So in error analysis, this type of constants we don't consider. Okay, constants we don't consider. You consider only x power n. So x power n means n into delta x upon x. That's it. Even though constant is present, we don't consider constant. So these are the important equations in error analysis. Okay, note it down all the equations. Okay. So in this error analysis, the first important model. Okay, so per each model, I will do one question and one question as a homework. Okay, so I have minimum 2 questions, 3 questions I have. I will do one question, second question homework in that way. So determination of first model is determination of G means acceleration due to gravity by simple pendulum. So in mains, we have one chapter experimental skills. Experimental skills. So in experimental skills, we will do all these models, finding G, finding Young's modulus. Okay, so we will do some different type of models. So determination of G by simple pendulum. So here we know how to find time period of a simple pendulum, 2 pi root over L upon G. So by simplifying, we get G equal to 4 pi square into L upon T square. So I want to find delta G upon G. Okay. So the estimation of error in G value, gravity value. So delta G upon G equal to, I told you already 4 pi square is a constant. 4 pi square is a constant. So constants we don't consider in error analysis. So this 4 pi square we don't consider in error analysis. Then after we have division is present. Division is present. So in errors, the division converts to addition. And L power 1 here. So 1 into delta L upon L. Next T square. So 2 into delta T upon T. Now this formula we have to follow to find percentage error in calculation of acceleration due to gravity. Sometimes, and what is the meaning of L over here? What is the meaning of L? Length of the simple pendulum, correct? But how to measure length of the simple pendulum from point of suspension up to center of gravity of the bob? So it is the exact meaning of length of the pendulum from point of suspension up to center of gravity of the bob. So for example, in the question, this is given L means length of the string, and here this is given R, radius of the bob. Therefore, what is the length of the pendulum? L equal to, so length of the string plus radius of the bob. Okay, so in the question, length of the string information is given, radius information also given, then how to find gravity? Okay, so the same formula I'm taking. So G equal to 4 pi square. The basic formula is capital L upon T square. Okay, L means length of the pendulum. Length of the pendulum is L plus R. So G equal to here 4 pi square. In the place of capital L, we are writing L plus R upon T square. Okay, so from this equation, I want to find delta G upon G. So I told you already, in dimensional analysis, constants we don't consider. Okay, then after, first of all, here we have division. So in errors analysis, this division converts to addition. Now you please answer. So what about L plus R? L plus R, it is in the form of addition property. This addition property. For addition property, so we have delta x plus delta y upon x plus y. Same thing here, if we apply, it is in the form of addition property. Now what we get, delta L plus delta R upon L plus R. So it is about numerator. This numerator is completed. So coming to denominator, we have t square. So 2 into delta t upon t. Okay, so this we can follow. And small l means length of the string and r means radius.
Sir,
Please.
in the original formula, t equals to 2.2 under root L by J, we
Yes.
can't do direct error analysis. Why is that?
So
We
generally,
will get a different formula.
we are finding g value now.
Yes.
Okay, we are finding g value. See, for example, even though if you apply over here, first of all, t square equal to what we get, 4 pi square into L upon G. Okay, so whatever we are finding, so we are finding G value. So in this, in all these equations, Z means resultant, means what we are going to find out. So what we are going to find out, that will be keeping on left side. Same thing here. So we cannot apply errors analysis directly in this formula. So what is the value we are finding? That value first we have to write on left side. Then after we have to apply error analysis in this determination of G value. Okay.
Okay, sir.
So,
Please.
so how the error is determined?
I will do the question. So for example, maybe in 11th standard, you studied about Vernier calipers, screw gauge.
Yes, sir.
Okay, so let us do 1 or 2 questions.
So what is capital L?
Capital L is length of the pendulum. Capital L, length of the pendulum. Small l is length of the string. Okay. Now see the question. In this question, time period already given, t equal to 2 pi root over L by G. The formula is given. So here capital L is given directly 10 centimeter. 10 centimeter with 1 millimeter accuracy. Okay, that means it is a delta L. Okay, so it is L 10 centimeter. Delta L is given 1 millimeter. Now time period of oscillation is about 0.5 second, and time of 100 oscillations is measured. Okay, 1 second resolution. So 1 second resolution means same thing here. It is a delta T value. Okay, delta T value, 1 second resolution. Therefore, now I want to find G value. So G equal to, what is the formula? 4 pi square into L upon T square. So delta G upon G equal to, I'm writing directly, delta L upon L plus 2 into delta T upon T. So what is the delta L value is given in the question? Delta L, 1 millimeter, correct? Delta L is given 1 millimeter. So this 1 millimeter is nothing but 0.1 centimeter upon, so what is the L value is given? 10 centimeter. Okay, L value. So 10 centimeter plus 2 into, so in this question, delta T means a time period, same capital T time period. But in the question, it is given 100 oscillations. Okay, 100 oscillations. Now listen. So T equal to n times capital T. So it is a capital T is a time taken to complete one oscillation. Now to complete n number of oscillation, so T is the time. Okay, to complete n number of oscillations, T is the time. Okay, so this type of information is given. So here, what is the time to complete each oscillation? This capital T value is given 0.5 seconds. Okay, now you please answer. N means a number. It may be 1 oscillation, 2 oscillation, 3 oscillation. It is a number. Okay. So from this, what is the value of delta T upon T equal to what we get? Delta T upon T equal to what we get? It is a number, a constant value. And a
Delta
constant,
capital T by
so
T.
delta capital T upon T. So directly here, now in the place of delta T upon T, I'm replacing with delta small t upon T. So from this equation, so centimeter unit cancel out. So 0.1 upon, so we are finding in terms of percentage. So into 100%. So it is nothing but 0.01 plus 2 into, so what is the delta T we have after measuring 100 oscillations? Delta T value is 1 second. So this delta T value is given 1 second. Then after, so what is the value of this small t from this equation? What is the value of small t from this equation?
50.
50, because 100 oscillations, for each oscillation time period is 0.5 seconds. Okay, therefore this small t value 50 upon 50 into 100%. And by simplifying, so we have the answer. So please go through it. Do you have any doubt? Okay, same type of model. Now you try this question as a homework. Okay, wait. I will do this question. So in the question, see specifically length of the string is given and diameter of the bulb also given. So length of the string is given, diameter is given. So if you know diameter means we can find radius also. Okay, what is radius value equal to? 1.28 centimeter. So in the question, length of the string is given, radius of the bulb also given, and we have to find G, maximum percentage error in the gravity value. So delta G upon G equal to, so what is the formula we have? Delta L plus delta R upon L plus R plus 2 into delta T upon T. So you got this equation. This equation we followed because in the question length of the string is given, radius of the bulb also given. So this equation we are following. Okay. Then after, but in the question totally how many number of oscillations are given? 10 oscillations are given. Okay. So time for 10 oscillation. So T value directly given 20 seconds. Now you please answer. In the place of delta L, see what is the length of the string is given in the question. Length of the string is given 98.0 centimeter. That means delta L equal to, what is the error?
0.
0.1. So why? Because after decimal we have one position is given. After decimal point we have one position, so 0.1 centimeter. Okay. So for example, this length is found out by using meter scale. On the meter scale, what is the each division value? On meter scale, what is the each division? 1 millimeter.
1 centimeter.
Each division, 1 millimeter.
0.1 centimeter.
So 0.1 centimeter. Okay, so after decimal, one position is given, so 0.1 centimeter. For example, after decimal, if two positions are given, 0.01 centimeter. After decimal, if three positions are given, 0.001 centimeter. Accordingly, we follow. Then after here, radius is given, R equal to 1.28 centimeter. Okay, that means here, so after decimal, two positions means they followed Vernier calipers. Okay, Vernier calipers to measure this radius value. So now you please answer, what is the value of delta R here?
0.01.
So 0.01. Then after, so I'm taking directly here, this is 20 seconds. So directly this value I'm taking as 20 seconds. So it is given 20.0 seconds. Now what is the T value here? Yeah, any one of you.
.1.
So delta T will be 0.1.
0.1. This whole thing into 100%. This whole thing into 100%, and let us do it. So we have the total information we have, and we will do simplification. Okay. Next, this is the homework question. You try this one. Okay, same model. Like first question.
So
Please.
won't delta T be 0.1?
So 0.1. Sorry. I think this delta T is 0.1 seconds, and this is 20 seconds. But you got it now? This delta T 0.1 seconds, this T is 20 seconds. 20 or how much is given? 20 seconds. Now this question you try as a homework, same type of model, okay? So it is our simple pendulum finding acceleration due to gravity. So next model 2 is, I want to find out Young's modulus.
So
Please.
in that question, 20 seconds is given for some number of oscillations now. So T will have to calculate now.
So total how many number of oscillations are given? For 10 oscillations, 20 seconds, correct? In this case, for one oscillation, what is the time taken? For one oscillation?
2
seconds.
Okay, or otherwise do one thing. So here I'm taking T equal to N times T. Therefore, delta T upon T equal to delta capital T upon capital T. So the first value is as it is plus 2 into, so this is a term as it is, 2 into in the place of delta T upon T. Now what we can replace with delta small t upon T. So this T is the time taken for 10 oscillations. Therefore, now in the place of T, what we can replace with? In the place of T, what we can replace with? 20 seconds.
20.
Okay, 20 seconds. And what about delta T value is?
0.1.
0.1 seconds, and simplify it. Okay. Now write down second model, Young's modulus by Searle's experiment.
Sir, in the previous question, how did you get delta T?
Same thing, after decimal, one position is given. After decimal.
Okay.
Okay. So Young's modulus by Searle's experiment. So Young's modulus means what is the formula we have? F into L upon A into small l. And what is the meaning of small l here? Elongation. Small l is the elongation of the wire. And capital L means its original length. Original length of the wire. So Young's modulus equal to, in the place of force, for example, in this experiment, so they will take a wire and mass M is suspended. Mass M is suspended. Now in the place of force, now what we can write? That is mg. So mg, L means original length of the wire, and small l is the elongation. Elongation due to load suspended. Small l is the elongation of the wire due to load suspended. So A means area of cross section of the wire. So area of cross section of the wire is a pi r square into L. Small l is the elongation. That implies y equal to, in some questions, they are giving diameter. So by taking diameter, so what we get? Y equal to mg L upon pi into, so d square upon 4 into elongation. So therefore, finally we have Young's modulus equal to 4. It goes to numerator. So 4 into mgl upon, in denominator, pi d square L. Now this equation we have to follow to find percentage error in the measurement of Young's modulus.
Sir, I have a doubt in the above question.
Please.
Sir, go to the above question, sir. Previous question.
This question.
Yes, sir.
Please.
Sir, here
Uh,
it is given 10 oscillation taking 20 seconds.
Correct.
Then we will calculate the time period that is equal to 2 seconds,
Correct.
right?
Mm.
Sir, then sir, why you have written that is 2?
See, generally here, this 2 is, what is the formula? This 2 is coming from the formula. G equal to, what is the formula? 4 pi square into L upon T square. Na? This is T square. We get 2 into
No,
delta
sir.
T
I'm
by T.
asking that
Uh,
what we will write in the place of T, that is will be 2 or 20.
So now this equation we have to follow. This equation, why? Because we have number of oscillations are given. So number of oscillations are given. So this equation we have to follow. Now what is the value of small t? Small t is the time taken. Small t is the time taken to complete 10 oscillations. So
Okay.
what is the time taken total to complete 10 oscillation? Is it 2 seconds or 20 seconds?
I got it. I got it.
Got it, no? For example, in the question, if you have given only one oscillation is given, if only one oscillation is given, you follow first formula, this formula. If only one oscillation is given, if more number of oscillations are given, so we have to follow this formula. Okay. Yeah, write down the question. Okay, I'm doing second question. So first question, third question as a homework. Okay. See the question. So in this question, diameter is given 0.05 measured by a scale of least count. So 0.001 centimeter. Okay, that means this value is delta D. Okay, delta D. Then after length of the wire is given 110 centimeter. This length is measured by a scale of least count 0.1 centimeter. This 0.1 centimeter is delta L. Okay, then after weight is given mg. Weight mg is given 15 newtons. Okay, extension is given, means elongation, small l. So elongation is given 0.125 centimeter. This elongation is measured by a scale of least count 0.001 centimeter. So the whole information is given. Now we have to find maximum percentage error in Young's modulus. Okay, so in this question, diameter is given. If diameter is given, how to find Young's modulus is a 4 into mgl upon pi d square small l. So here for in error analysis, 4 constants, so we don't consider. In the same way, mg also weight is given. So in the running of the experiment, the same load we are taking, 15 Newton we are taking. So this 15 Newton is a constant. So this 15 Newton also constant. Okay. Is it clear?
Yes, sir.
Then after, so pi also we don't consider. Pi also a constant we don't consider. Therefore, only for the remaining terms, let us apply the error analysis. Now delta y upon y equal to, I told you already, if a division is present, converts to, so this division converts to addition. This multiplication also converts to addition. Now what is the first value is L? That is nothing but delta L upon L. Then after here, d square is given. So first power, that is 2 into delta d upon d. So it is a power L. So L power is 1. So 1 into delta small l upon L. So small l is nothing but extension, elongation. Therefore, delta y upon y, we are finding in terms of percentage. equal to what is the value of delta L is given in the question. You refer the question, what is the delta L value?
0.1.
0.1. So delta L is given 0.1 centimeter. And what is the value of capital L is given in the question?
110.
Capital, okay, 110 centimeter. So both are same units, so no need to convert. Then after, and what about delta D is given? D means diameter. So delta D is given 0.001 centimeter, 0.001 centimeter. In the same way, diameter of the wire. So how much diameter is given? 0.05 centimeter. It is given 0.05 centimeter. Then after, small l means elongation. So how much elongation is given? 0.125 centimeter. So 0.125 centimeter. Then after, delta L. And what is the value of delta L is given? 0.001 centimeter. So 0.001 centimeter. So here the same system of units, so no need to convert. For example, if one value given in millimeter, one is given in centimeter, in those cases we have to do conversion. Okay, if one is given in millimeters and one is given in centimeters, in those cases definitely we have to do the unit conversion. But in this case, all these are in same system of units, so no need to convert. And we will do simplification. Delta L is given, the whole information we have into 100%, and simplify it, we get percentage error in the measurement of Young's modulus. Okay. So rest of the two questions homework. Okay, I will post the homework questions also separately in the group. Okay, it is second method. Okay, finding Young's modulus. So coming to third model, finding specific heat constant, of solid. Finding specific heat constant of solid. Listen, for example, initially we have, it is a calorimeter with liquid. Okay, calorimeter with liquid. So in the question, for example, I'm taking MC. Okay, so MC is mass of the calorimeter, I'm taking CC, where that means specific heat constant of calorimeter. Then after, I'm taking ML, okay, mass of the liquid in the calorimeter, mass of liquid in calorimeter. Then after, I'm taking CL, means specific heat of liquid, specific heat constant of the liquid. And initially this total is at the temperature T1 degrees Celsius. Okay, so calorimeter and liquid. So calorimeter and liquid initially at the temperature T1 degrees Celsius. And here I'm taking a hot solid. It is a hot solid. Its mass MS, specific heat constant CS, its temperature is high, T2 degrees Celsius. Then after this solid, we are dropping into the calorimeter. What is the total mixture is? Calorimeter, liquid, and a solid. So it is the final mixture. For this final mixture, resulting temperature is T. T degrees Celsius. Okay. Now I want to find this CS value. So in the question, T1 will be given, T2 will be given, resultant temperature T also will be given. So we have to find specific heat constant of the solid. You please answer, what is the principle of calorimetry? Heat lost by,
heat gain equals to
so
heat
heat lost by high temperature body equal to heat gained by low temperature body, correct? The same principle, so let us follow. Okay, so in this question, who is losing heat energy? Who is losing heat energy?
Solid.
Solid. So how much? So in the case of solid, so initially temperature T2 degrees Celsius and finally temperature is T degrees Celsius. So this whole mixture resulting temperature is T degrees Celsius. Okay. So heat lost by low temperature. So heat lost by high temperature body means hot solid. So what is the formula? Q equal to mc delta theta or latent heat energy or both? What we have to write? Heat
MC
lost
delta
by,
theta.
okay, so correct. Heat lost by hot body equal to heat gained by cold bodies. Heat gained by cold bodies. So hot body means solid, okay, solid material we have to follow. That is M S C S delta theta. So how much temperature it lost? So it is loss of heat energy. Loss of heat means how much temperature it lost. So temperature lost means what we have to do it. T2 minus T or T minus T2.
T minus
T2
T.
minus T.
So how
T2
much
minus T.
T2 minus T. How much temperature it lost? For example, initially, for example, it is 100 degrees Celsius and finally equivalent temperature 80 degrees Celsius means how much temperature it lost? 20, no? How much temperature it lost? So 20. So that means here what we can write T2 minus T equal to, so heat gained by cold bodies. So how many cold bodies we have? Calorimeter and liquid. So in the case of calorimeter, what is the initial temperature is? In the case of calorimeter, T1 degrees Celsius, and what is the final temperature is? T degrees Celsius. You please answer. What is the heat gained by calorimeter? MC, CC, what we can write? T1 minus T, okay, or T minus T1?
T minus T1.
T minus T.
T minus T1. Next, we have liquid also present, mass of the liquid and Cl, same thing T minus T1. But the question is what we have to find out? Cs, specific heat constant of the solid. So whatever, for example, okay, this Cs value, so or Cl value, anything we can find out, okay? So for example, okay, so from this equation, Cs equal to what we get? Do one thing, do a small correction in the question. So let us find out specific heat constant of liquid. Specific heat constant of liquid. Miss Cl, let us find out. So from this equation, we have ml Cl into T minus T1 equal to, we get ms Cs T2 minus T minus mc Cc T minus T1. Now we are finding Cl value, specific heat constant of liquid I want to find out. So you divide with ml T minus T1 on both sides. Divide with ml T minus T1 on both sides. Then what we get? Cl equal to, it is ms Cs T2 minus T. We are dividing with ml into T minus T1 minus, so here we are dividing with ml T minus T1. So what we get? mc Cc upon ml. So why? Because T minus T1 cancel out. Okay. So for example here, if I'm taking, so is it clear first of all? This derivation is
Yes, sir.
Yes, sir.
okay. Then after this whole value, for example, let it be x1, this whole value, let it be x1, and this value, for example, let it be x2. Okay, now we have x1 equal to ms Cs T2 minus T upon ml into T minus T1. Okay, from this equation, you please answer how to find delta x1 upon x1. How to find delta x1 upon x1? For example, in the question, so in the measurement of mass of the solid, also some error is given, least count is given. Okay, if not given, take it as 0. If given in the measurement of mass of the solid, also for example least count is given. So how we can do it? Now this multiplication converts to addition, this multiplication converts to addition, this division also converts to addition. So first of all, in the case of ms, what we can write according to error analysis, that is delta ms upon ms. And what is the meaning of delta ms? Least count in the measurement of mass of the solid. If least count is not given, so take this value as 0. It depends upon the question. Considering, not considering, depends upon the question. In the question, for example, least count of the mass of the solid is given, so we have to consider. If not given, so take it as 0. Then after plus, and for a given material, specific heat is constant or variable. For a given material, constant, so no need to consider. Then after, you observe here T2 minus T means it is in the form of addition property or subtraction property. Subtraction. So according to subtraction, what we get in the numerator, delta T2 minus delta T or delta T2 plus delta T.
Plus delta.
Plus
So errors always we have to add. In denominator, T2 minus T or T2 plus T2
minus.
Minus 2.
Then after this division, okay, this division also converts to addition. In the place of ml, now what we can write, delta ml upon ml. Plus again, it is in the form of, okay, subtraction property. So according to subtraction property, what we get, delta t plus delta t1 upon, in denominator, t plus t1 or t minus t1, t minus t1. Now this is the way to find delta x1 upon x1. Then after, and what is the x2 value we have? So we have x2 is this much, mc cc upon ml, mc cc upon ml. From this delta x2 upon x2 equal to, so we know multiplication converts to addition, division also converts to addition. In the case of mc, what we can write, delta mc upon mc. And we know for a given material, specific heat is constant, so no need to consider, plus, and here we get delta ml upon ml. So this is the way to find out percentage. So if you know delta x, so it is delta x2 upon x2.
Sir, if in question the mass of solid is given like 30 kg, so do we take error to be 1
See,
kg?
generally here, they specify like 30.0 kg in that way, 30.0 or 30.00. Okay, that will
And
be
if
given.
just 30 kg, then error is
See,
0.
general. So for example, just 30 kg is given means there is an absolute value. Okay.
So error will be 0. No?
Okay.
Understood.
Then after, next model. So on this model, I don't find any questions. So you please refer different publications. If you get any question, you follow this procedure. Okay. Okay. Next model
So,
number. Please.
in the end, do we have to do delta x1 minus delta x2 plus delta x2 upon x1 minus x2?
Now listen. So we have delta x1 upon x1. We got some value. Correct. Delta x1 upon x1. We got some value. Therefore, do one thing. Now, delta x1 upon x1 equal to this much value I have. Therefore, find out delta x1. Now, what is the delta x1 value is this value into x1, correct? In the same way, we have delta x2 upon x2. So delta x2 upon x2, so we have this value. So we got this much value. From this equation, delta x2 equal to what we get, this value multiplied with x2. Okay. Now listen here. In this case, now we are finding specific heat of liquid. It is x1 minus x2. So specific heat of liquid equal to, we have x1 minus x2. If it is x1 minus x2, so how to find delta CL upon CL? We have to follow which property? subtraction, correct? From subtraction property, what we get? Delta x1 plus delta x2 upon x1 plus x2 or minus x2?
Minus x2.
Minus x2. Okay, so first of all, we have to find x1 value. Okay, so according to information, first we have to find x1 value. If we know x1 value, we can find out delta x1 also. Then after, so from this equation, we have to find x2 value. If we know x2 value, so delta x2 also we can find out. So finally here, x1 value we have, x2 value we have, delta x1 we have, delta x2 we have, and how to find the CL? For example, I want to find only delta CL. For example, I want to find only delta CL equal to, we get delta x1 plus delta x2 upon x1 minus x2 into CL. But how to find the CL value? You take this equation. Okay, already we calculated x1 value from this equation. We calculated x1 value from this equation. Okay, and already we calculated x2 value from this equation. So if you know x1 value, x2 value, so we have CL value. We have CL value. So therefore, we have CL value, x1 value, delta x1 value, x2 value, delta x2 value. We can find out how much percentage. Okay. Is it clear?
Yes, sir.
Okay. So in the final, we are taking subtraction property only. Okay.
So specific heat of solid is constant.
So generally, we are taking low temperature conditions. At low temperature, specific heat of the material is constant with the temperature. Okay, at very high temperatures, specific heat changes with the temperature. But generally, so as per the question's information, they have given low temperature like 50 degrees Celsius, 100 degrees Celsius. So at low temperatures, specific heat is constant with the temperature. Okay, at very high temperature, specific heat slightly changes. Okay, but generally in our practical conditions, we follow specific heat is constant with the temperature. Okay.
So if mass is given as 30.0 kg, then we have to consider error.
30.0, if it is given, we have to take the error.
And if it's only 30, then no error.
No error. Okay. Right. Next one is, okay, so in sound chapter, resonance tube experiment is completed. Resonance tube experiment in waves chapter. Yeah, anyone? Resonance tube experiment.
Yes, it is done.
It is done now. Okay. All right. Now, I think you know first resonance, second resonance with anti-correction. You know anti-corrections also.
Yes, sir.
Okay. So next model, I'm taking a resonance tube experiment. So from resonance tube experiment, we have to find the speed of the sound wave. Speed of the sound wave, okay, in air medium. So for example, at a first resonance, so it is a water column, and it is L1, okay, length of the air column or length of the resonating air column. And what about, so here at open end, antinode will be formed or node will be formed? At open end, antinode or node?
Antinode.
But okay, but antinode exactly formed at open end or slightly above?
Above.
Slightly above.
Slightly above. So slightly above, antinode will be formed. At closed end, node will be formed. Or closed means a denser medium. A denser medium, node will be formed. So therefore here, in first resonance, the stationary wave will be formed like this. So it is antinode, displacement antinode, and this is displacement node. Now this length is nothing but anti-correction. And what is the distance between antinode and the node? Lambda by 4 or lambda by 2? Between antinode and the node, lambda by 4.
Lambda by 4.
And this is L1, length of the first resonating column. Okay. Therefore, so what is the value of lambda by 4 is equal to L1 plus E. It is at a first resonance. Then after same figure, I'm drawing at a second resonance. So it is the given resonance tube. And here it is the water column. So this length of the resonating air column, L2. And we have antinode will be present slightly above the open end. Okay, so it is antinode. Same thing, this position is a displacement antinode and this position is displacement node. So between antinode, this is equal to lambda by 2, and between antinode, its next node, this distance lambda by 4, and we know this is end correction. Therefore, lambda by 2 plus lambda by 4, 3 lambda by 4. So therefore, 3 lambda by 4 equal to L2 plus E. Okay, so by simplifying them, by simplifying these two equations, we get end correction equal to L2 minus 3L1 upon 2. By simplifying both equations, we get lambda equal to 2 times L2 minus L1. By simplifying, we get these equations. But the question is, the experiment is we have to find the speed of the sound wave in air medium. So V equal to F lambda. Therefore, V equal to F into, what is the lambda already we have? 2 into L2 minus L1. Now, this is the equation we have to follow in resonance tube experiment. So here, in the determination of speed, if we take error analysis, so delta V upon V equal to, so two constants we don't consider. So delta F upon F, so this multiplication converts to addition. So in the place of L2 minus L1, what we have to apply? It is in, so here it is a subtraction property. So what we get, delta L2 plus delta L1 upon L2 minus L1. Now this is the formula we have to follow to find percentage error in the measurement of speed of the sound. Okay, so let us try one question. Okay, see the question. So we have to find maximum possible percentage error in speed of the sound. Okay, so delta V upon V into 100% equal to delta F upon F into 100%, simply delta F upon F plus delta L2 plus delta L1 upon L2 minus L1, this whole thing into 100%. Okay, now you please answer. In the place of delta F upon F, so how much percentage in frequency? Go through the question.
1 by 340.
No, already it is given 1%.
1%.
1% already given. Okay, no need to find separately. Already given it is 1% in the measurement of frequency, 1%. So if it is 1%, delta F upon F is 1 upon 1% means 1 upon 100. Okay, so it is 1 upon 100, the first value, then plus. Now you please answer. What is the value of delta L2? So it is L1. The first reading is L1. It is L1 and it is L2. Now you please answer. What is the delta L2 value?
0.1.
1 and delta L1
0.1.
0.1 upon L2 minus L1, 74 minus
54.
20, 54 centimeter, this whole thing into 100%. So we have the answer. Okay, so I have two more questions are there, same model. So I will post the remaining two questions as a homework. Okay?
Sir,
Please.
So in the above question, 340 is an F.
340 in the measurement of frequency of tuning fork, already they have given the percentage error. In the measurement of frequency of tuning fork, they have given already the percentage error. Okay. So it is a delta F upon F already given in the question. Okay.
Sir,
Please.
can you go to that part when you derive this formula?
This one.
Yeah. Sir, after calculating E, what you did?
Lambda. By simplifying, we get lambda value also. For example, do subtraction. By subtraction, 3 lambda by 4 minus lambda by 4, how much? By subtraction, 3 lambda by 4
Lambda by
minus
2.
lambda by 2. And what is right hand subtraction? E cancel out. E cancel out. Subtraction. Then
Yes,
what
sir.
we get? L2 minus L1. Correct?
Yes, sir.
Therefore,
Okay, sir, got it.
so if you know lambda value, so we can find out speed of the sound wave. V equal to F lambda formula. Okay. So do you know all these models? So shall we continue? Or if you know all these models, then we go for one more concept. That's up to you. So do you know all these concepts, finding percentage? These type of questions. So shall we continue the same topic or we go for next one more?
Sir, next one.
The next one.
Next topic.
Okay, next topic means shall we go for semiconductors or let us continue the same errors
Sir,
analysis?
Error analysis only.
Okay.
Next.
So I think model number, next is model number 5.
Sir, when will give break?
Around 9:30. Okay.
Sir, will EM waves be completed in the next lecture?
So I think EM waves already, it was done in regular classes now. EM wave.
Yes.
So then I will do only questions. So in EM waves, I have something like around 6 to 7 questions I have. Okay, those 6 to 7 questions, it covers the entire chapter. Okay.
Sir, transistor is there in portion.
Yes, for main syllabus, it is there, transistors.
Okay.
It was done in the regular classes, transistors.
Sir, EP sir said that it was cancelled.
It was cancelled.
Yeah, he sent it on the group that transistors were cancelled.
Okay, so then, so generally in semiconductors, the important concept is transistor only. So if it is cancelled, then we have to discuss only diodes, PN junction diode, the questions belonging to PN junction diode. That's it. If there is no transistors in the syllabus, why? Because this year maybe because of COVID, they may cancel. Okay. Then, so generally here in semiconductors, I gathered more number of questions depends upon transistor. Okay. So then I will discuss only PN junction diode. Okay, PN junction diode, those questions. Okay. Okay, if you want, I will send you the video links of semiconductors. You please go through it. Okay. If you want transistors in detail.
Sir, can
Sir,
you send a
reduction
link
in
of EM waves?
EM waves, sorry,
EM
I'm not. EM waves, you want?
Yes, yes, sir, I want.
Then you please text me personally. I have video links of EM waves. I will send you. Okay.
Sir, I don't have your number.
I will share. I will share definitely. Yeah, write down. Next model is verification of Ohm's law.
So the reduction in CBSE syllabus is considered for JEE mains.
See, generally here, NTA, it has to announce officially. So generally CBSE, they announced it according to their board examinations point of view. Okay, CBSE is different, NTA is different. Clear? Okay, CBSE, they removed transistor part. Okay, that means in CBSE board examinations, they removed transistor part, but NTA, they have to announce officially. NTA different, CBSE board is different. Okay. Yeah, write down. So verification of Ohm's law is resistance equal to V upon I. then what we get? Delta R upon R equal to, so division converts to addition. So delta V upon V, and it is delta I upon I. So it is one formula. In some cases, how to find the resistance of a wire? Rho L upon A. Rho means resistivity, specific resistance, equal to V upon I. So that implies from this equation, rho L, A means area of cross section of the wire. So pi d square upon 4. D means the diameter of the wire. Okay, equal to, on right hand side, V upon I. V means potential difference across the wire, and I means current passing through the wire. Therefore 4 to numerator, so 4 rho L upon pi d square equal to V upon I. So therefore from this equation I want to find the resistivity rho value. So resistivity equal to, we get pi d square into V upon 4 L I. So from this equation, let us find out errors in the measurement of resistivity. So delta rho upon rho equal to, so pi a constant, 4 constant. Okay, no need to consider. So if multiplication is present, division is present, it converts to addition. So in the place of d squared diameter, we get 2 into delta d upon d plus, and V means the potential difference, we get delta V upon V plus, it is only L, means L power 1. So 1 into delta L upon L. L means length of the wire. Okay, L, length of the wire. Plus we have I power 1. So it is 1 into delta I upon I. Now this is the formula to find percentage error in resistivity. So it is resistance and this is resistivity. Noted down?
सर डी स्क्वायर इसी के लिए 2 आ गया है.
Just a minute. Please. What is the doubt?
I डी स्क्वायर है इसलिए डेल्टा डी अपॉन डेल्टा डी आगे 2 आया ना.
See, generally here d square multiplication converts to addition. V means delta V upon V, L delta L upon L, I delta I upon I. Okay. If any power is present, the power we have to write first. Okay. Yeah, write down. I will do one question. Second question is a homework. Okay. Okay. Now see second question. Focus on second question. So in the previous question, okay, that means this information we have to follow. In the previous question, we have to find maximum possible percentage error in resistivity. Focus on second question. Okay. We have to find percentage error in resistivity. So I'm taking the previous formula. Delta rho upon rho equal to, so what is the previous formula? We have 2 into delta D upon D, 2 into delta D upon D, next plus delta V upon V plus delta L upon L plus delta I upon I. Now this equation we have to follow to find percentage error in resistivity. So you say in this case, what is the current I is given? I is given 10.0 amperes. That means what is the value of delta I?
0.1.
0.1.
0.1. Then after, what is the potential difference across the wire?
100.
100.0.
0.1.
0.1 error.
So delta 1, so 0.1 is the error, correct? Then after, what is the diameter is given? Diameter is
2
given.
millimeter.
So 2.00, correct. So delta D is 0.01 millimeter. Then after, what is the length of the wire is given? Length of the wire.
1.4.
So 31.4 centimeter. So what is the error delta L
0.1.
value? So 0.1. So we will do simplification. Okay.
Sir, correct significant figures means We have to take 31 or 31.4.
So all in correct significant figures. Okay, so so how to find significant figures? 10.0, how many significant figures?
3.
3. So all are having the proper so all are in proper significant figures they follow. So it has no meaning generally in the question. Okay. Okay, that means here up to 3 decimal places, this value is calculated. Okay, up to 3 significant figures, it is calculated. Up to 3 significant figures, it is calculated. Up to 3 significant figures, it is calculated in that.
Yes, sir. So we don't have to take again.
No.
Yes, understood.
So next one is, so it is about verification of Ohm's law. I have one more question I will post in the group as a homework. You try to do it. Okay. So next model is meter bridge. Next model, meter bridge.
So in the
Please.
first question, the answer has to be in 3 significant figures.
This question?
The first part.
Find resistivity. So generally here, what we have to find resistivity. Resistivity means simply what is the formula rho equal to. So we know resistance equal to rho L upon A. A means pi d square upon 4. Correct? Therefore, from this equation, I want to find rho means what we get. What is the formula is? It becomes 4. Rho value is pi r d square upon 4L. You try to recall significant figures in multiplication or division. In multiplication or division, so here the final result should retain as many as significant figures with the number with least significant figures. You know the properties? The role of significant figures in addition, subtraction, in multiplication, division. You know those points?
Yes, sir.
In multiplication division, what we have to take, the resultant should retain as many as significant figures as the number with the least significant figures. So here, what is the number with the least significant figures? 3 significant figures is the least one, or 4 significant figures is the least one?
3.
So up to 3 significant figures, we have to find the resistivity value. Okay. Yeah, right on. Next one is meter bridge. Okay, in brief, in meter bridge, so what are the corrections we have? It is a copper strip, and here we have a central copper strip, and here we have another copper strip. So for example, it is point A, and for example, it is point B, and between them we have a wire of length 1 meter. 1 meter means 100 centimeters. So in the left gap, so generally we connect unknown resistance of the wire, unknown resistance of the wire. In right gap, we connect R. That means resistance box, resistance. And here between A and B, we connect a battery. Okay, so in brief, I'm drawing the figure. Okay, so between A and B, so we connected a battery, and here from this point, a galvanometer we connected to a jockey. And you know experimental procedure. And for example, I'm taking this point P is the null point. Now this is length L. If it is length L, now it is equal to 100 minus L. Okay. And what is the formula here in meter bridge? How to find the X value?
X upon L should be equal to R upon 100 minus L.
R upon 100 minus L. Or else, from this equation, we have X upon R. X upon R equal to, we get L upon 100 minus L. Then after, X upon R equal to, so for example, this L value I'm taking as L1, and this value I'm taking as L2. So it is in the form of L1 upon L2. So if you know L1 value, automatically can we find the L2 value also or not? If L1 is 40 centimeter, it is 60 centimeter. But as for easy convenience, I'm writing in the place of L as L1 and in denominator as L2. Therefore, from this x equal to, we have R into L1 by L2. Now you apply error analysis, then what we get, delta x upon x equal to delta R upon R plus delta L1 upon L1 plus delta L2 upon L2. Now this is percentage error in the measurement of unknown resistance of the wire. Okay, so have you done anti-corrections in meter bridge in regular classes? Anti-corrections in meter bridge?
No, sir.
Anti-correct. Okay, so what is the meaning of anti-correction exactly in meter bridge? Listen, so here we have a screw is present, and here also we have a screw is present. Okay, so about the screw, so we are taking some wire around the screw wire or not? In the same
Yes,
way,
sir.
about the screw also we are taking some wire. But so for example here, for example, if I'm taking 2 centimeter wire, so we wind it about the screw. For example, I'm taking 1 centimeter wire, so we wind it about the screw. Same here, for example, 2 centimeter wire, we wind it about the screw. But through this 1 centimeter wire, through this 2 centimeter wire, so through them current is passing, not passing?
Passing.
Current is passing. But so we are taking, look at this 1 centimeter length around the screw, for example 2 centimeter length around the screw, current is passing, but we are taking those length into consideration in the derivation part?
No, sir.
No. So that is the anti-correction. So how to find this anti-correction means how much length, and here how much length. So how to find those anti-corrections? Write down please. Okay. So generally in experiment, in theoretical classes, we ignore this anti-correction value and we ignore this anti-correction value. Anti-correction means there is some length is present over the screw. Same, there is some length of the wire also present over the screw. So this length of the wire over the screw, this length of the wire over the screw. So generally we don't consider, but through them also current is passing. Okay, so those are the anti-corrections. So how to find anti-corrections? Write down please. In meter bridge, some extra length is present under the metallic screw, under metallic screws at point A and at point B. At point A and at point B. So there is some additional length. There is some additional length, alpha and beta should be included. Alpha and beta should be included at the ends. So here alpha and beta are called anti-corrections. Alpha and beta are called anti-corrections. So you please answer. So here the formula is x upon r equal to what is the basic formula we have? L upon 100 minus L. So this L means from at left side and 100 minus L is right side. So it is L, it is 100 minus L. So here at this left side, how much anti-correction is present? Alpha length is present, and here beta length is present. So it is alpha length, it is beta length. So what is the exact length? Now in the place of L, what we have to write by taking anti-corrections into consideration? It is exactly equal to L, or L plus alpha, or L minus alpha.
L plus alpha.
L plus
So
alpha.
in the place of
Plus
L,
alpha.
so we have to take L plus alpha by taking anti-correction into consideration. So it is 100 minus L on the other side, 100 minus L, but here how much length is present? How much extra
Plus
length is
beta.
present? Plus
Beta.
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 So 100 minus L plus beta. Okay, then how to find alpha value and how to find beta value? Okay, the procedure we have to do it. So finding alpha and beta. Okay, listen. So for example here, in the place of R resistance, so we have two resistances. For example, in the place of X, I'm taking R1 resistance. In the place of R, R2 resistance, I'm taking. Okay, so in the left gap, R1 resistance, in the right gap, R2 resistance. Okay, then after I'm taking L1 is length. L1 is a balanced length. Okay, it is L1. In the place of L, I'm writing L1. So L1 is the balanced length. If L1 is the balanced length, now other side, what is the length? It is 100 minus L1. 100 minus L1. Therefore, now what is the formula here? You apply this formula, then what we get in the place of X in left gap. In left gap, so here X means left gap resistance and R means in the right gap resistance. Okay, now what we get, and L1 is a balanced length. So in the place of X, what we can write? R1 upon R2, correct? R1 upon R2 equal to, so what is the balancing length here? We have L1 upon 100 minus L1 generally. But by taking anti-corrections, so here we get plus alpha and here we get plus beta. Then after, so it is one equation. The second one is we have to interchange. On interchanging R1 and R2. Now, okay, balanced length, I'm taking L2. Okay, L2 is a balanced length. Okay, that means now in the left gap, which resistance we have? In right gap, which resistance we have? In left gap, R1 or R2? We are interchanging R2. In right gap,
Unknown resistance on the right side.
okay, R1. So one length is L2 and this length is 100 minus L2. Then what we get? So you apply this formula. So X means left gap resistance and R means right gap resistance. In the place of X by R, here what we get? R1 by R2 or R2 by R1? R2 by R1 equal to, so I'm taking L2. L2 is the resonating length. So in the place of L upon 100 minus L, in the place of L, what we have to take? L2. Okay, so it is L2 upon 100 minus L2. By taking anti-correction, left side alpha anti-correction, right side beta anti-correction. Okay, left side alpha anti-correction and right side beta anti-correction. So therefore, we have two equations. And we have two equations and we have two unknowns. And what are the two unknowns? We have alpha, beta are the two unknowns. So we have two equations with the two unknowns. By simplifying, so write down alpha value. Alpha equal to R2 L1 minus R1 L2 upon R1 minus R2. In the same way, beta equal to, we get R1 L1 minus R2 L2 upon R1 minus R2 minus 100. Okay, so by simplifying both equations, now these are the anti-corrections, we get alpha and beta.
Sir?
Please.
Sir, why do we need to interchange the resistances?
So generally, we have to find alpha value, beta value now. Okay, to find alpha value, beta value, so to find the two unknowns, we require two equations, correct? To find the two unknowns, so we require two equations. So one equation is by taking R1, R2 as it is, and second equation is by interchanging. Okay, so in spite of taking a new resistance, simply take the same two resistances, simply interchange them and find the balanced length, the procedure. Now we get two equations. Okay,
Okay,
so
sir.
if you got it now, okay. So let us do one question. Okay, see here. In this question already, if we use 100 ohm, 200 ohm in the place of R and X, in the place of R and X. So we get null point deflection L equal to 33 centimeter. If we interchange the resistors, no, null point is 67 centimeter, and we have to find end correction. So here R1, R2 already given, L1, L2 already given. So we have to find the end corrections. So L1, alpha, beta, we have to find it. So already we have the equations. So in the equations, so we have to take the this given information. Okay. So already I have the solution. So you please go through later on. Okay. Okay. So one last, only two, okay, 5 minutes concept. One last concept. Finding next model. Finding focal length. Finding focal length by UV method. U means object distance and V means image distance. So finding focal length by UV method. So focal length means we have to find the focal length of mirror and focal length of lens. So we have two cases. So first case. In first case, I want to find focal length of mirror. You please answer, what is the mirror formula? Mirror
1
formula.
by
1 by
F
F equal to 1 by
by
U plus 1 by V. So from this equation, so first find F value by taking proper sign conventions. So you know U value positive or negative, okay, objective distance positive, negative, image distance positive, negative. So to find F value, so we have to follow proper sign conventions. Okay, so that is the first point. Then after, so by differentiating on both sides, 1 upon F differentiation is dF upon F square, correct? You know this one. What is the differentiation of 1 upon X? Differentiation of 1 upon X is minus 1 by X square. So from this differentiation of 1 by X equal to, it is nothing but minus 1 by X square into dx. So here no need to write minus. Why? Because here in this differentiation we have minus sign, in this differentiation we have minus sign, in this differentiation we have minus sign. That minus will cancel out on both sides. Okay, so simply 1 by F 1 by F differentiation is dF upon F square from this equation. In the same way, 1 upon U differentiation is 1 upon U square into du, and 1 upon V differentiation is 1 upon V square into dV. So basically this dF means error. So delta F upon F square equal to delta U upon U square plus delta V upon V square. Already here we calculated F value. So from this step already we calculated F value. If we know F value, and in the question object distance, image distances will be given. So can we find out the error in the measurement of focal length of the mirror, correct? Already we have F value focal length. So we know U delta U, we know V delta V. From this equation, we can find out error in the measurement of focal length. Okay. Now this formula we have to follow. In the same way, now second case, what is the lens formula? Lens formula is 1 upon F equal to 1 upon V minus 1 upon U. Same thing, first of all, find f. Find f by proper sign conventions. Find f by taking proper sign conventions. Then after same procedure, do differentiation on both sides. Okay, always we have to find the maximum percentage error. So if it is maximum percentage error, so in the place of minus, what we have to write, positive sign or negative sign to find the maximum percentage error.
Positive.
Positive. Okay, then what we get, the formula is same like previous or the different one? Delta f upon f square equal to delta v upon v square plus delta u upon u square. Always we have to find the maximum. Okay, maximum percentage error. So already here we have f value. So by using f value, we can find maximum error in the measurement of focal length. So we have already f focal length from this equation. Okay. So if you know already f value, by simplifying, we get maximum possible error in the measurement of focal length of the lens. So it is about error analysis. Okay, so do you know vernier calipers and screw gauge?
Sir, I have a doubt in this one.
Please.
Sir, I was disconnected for 2-3 minutes. Could you please explain why do we need to do the differentiation instead of using the error formula directly?
See, generally here, what is the meaning of error? So it is 1 by f equal to 1 by v minus 1 by u, correct?
Correct, sir.
Okay, so 1 by f equal to 1 by v minus 1 by u. Now we have to find delta f, the maximum possible error in the measurement of focal length. I want to find delta f. Now which formula can we apply here? I want to find, for example, delta f upon f. So listen here. If the question is finding percentage error in the measurement of focal length, if I want to find delta f upon f, so it is f square. So one f value, it is f square. One f value you bring to right hand side. Now we have delta f upon f into 100% equal to delta v upon v square, delta u upon u square. This whole thing into f. So we have, it is f square, one f value we are bringing to right hand side into 100%. Okay, so finally we want delta f upon f form. So this delta f upon f form, so this can be finding by taking errors analysis. Okay, generally this error analysis can be find out up to how much percentage changes. This
Or
error
around 5, right?
Around 5%. For small percentage changes, up to 5%, we can follow this error analysis. Now the target is I want to find delta f upon f. So this delta f upon f can be easily find out by taking differentiation on both sides. By differentiating, we are getting delta, so dx upon x squared, so we can bring one x value. Okay, so like this. So the easiest one is by differentiating on both sides. Okay.
So if we,
please.
sir, if we take LCM here, for instance, and if we write f as uv upon u minus v, then, and if we apply error,
So
the formula, will we get the same answer, sir?
uv upon u minus v, correct?
Yes, sir. And then if we apply error formula, will we get the same answer?
Same. So delta f upon f equal to, so first of all here, which principle we have to apply? Multiplication rule. So delta u upon u plus delta v upon v. In the place of division, what we can write? Plus. Then after, so in the place of u minus v, what we have to apply?
The subtraction rule. It becomes same as addition.
So delta u plus delta v upon what we get?
U minus v.
U minus v. So you verify by both methods. So you take this method and find out delta f upon f, and you follow this method, find delta f upon f, and you cross verify it. Okay.
Sir, it would be the same, right?
Just do so. It will be same. But for final verification, you please follow both methods and do verification. Okay.
Okay, sir. Okay, sir. Thank you.
So finally, we have to find out delta f upon f or delta f upon f square.
It depends upon the question. For example, in the question, find only delta f. Okay, then you follow this formula. For example, find percentage error. So then you follow this formula. It depends upon the question. Finding delta f or finding delta f upon f into 100%. Okay, it depends.
Okay, sir.
Sir, in the original subtraction addition formula, what was the maximum
So it is a maximum
limit?
See, generally here, for example, if I'm taking z equal to x minus y, okay, so generally here in the, so x is a physical quantity. And what is the meaning of physical quantity? Any quantity which can be measured. So while measuring x value, I got some error. And y also a physical quantity. So physical quantity means which can be measured. While measuring y, I got some error. No, x with error, y with error. Now we get z also with error, because z also a physical quantity. So this also a physical quantity which can be measured. While measuring, we have an error, that is z plus minus delta z. Okay, so in the place of z, by taking errors, so z plus minus delta z. So in the place of x, so it is x plus minus delta x, minus in the place of y, y plus minus delta y. Therefore, z plus minus delta z equal to x. So it is x minus y minus y. Then after we have plus minus delta x. Next we have minus plus delta y. So y minus plus, we are multiplying with negative sign. So by multiplying with the negative sign becomes minus plus, okay, delta y. So we have z equal to x minus y. So this z value x minus y cancel out. Okay, z equal to x minus y. So z value x minus y cancel out. So after cancellation, we have plus minus delta z equal to plus minus delta x minus plus delta y. I want to find a maximum percentage error in delta z. To find the maximum, okay, possible percentage error, I want to find maximum error delta z. To find a maximum error, so what type of sign conventions we have to consider to find the maximum possible error?
Add them.
So correct. So therefore delta z, so it is a maximum possible error equal to delta x plus delta y. But I want to find maximum percentage error. So delta z upon z. So delta z, we are finding maximum. Okay. So in the place of delta z, what is the maximum error we have? Delta x plus delta y. And what is the z value we have already? X minus y into 100%.
Sir, delta x and delta y can be greater than 5% in this case.
No, if greater than 5%, no, this analysis is not applicable. Over.
Sir, then what we do if greater than 5%?
So for example, if x equal to, I'm taking 10.0 plus minus 6%. Okay, so in this case, I think no differentiation now. So in the case of multiplication division, in multiplication division, so we differentiated. So you see the previous one, in first one, in the case of multiplication, z equal to x into y, we have z equal to x into y. Then we got delta z upon z equal to delta x upon x plus delta y upon y. So these results are according to differentiation. So in this case, strictly we have to follow the 5% limit. But in the case of addition, I think so, no need to follow the error limit. Okay, why? Because simply it is addition we are taking.
Okay, sir. So no limit.
In differentiation, we have to follow. So if whenever we are taking differentiation portion, so strictly we have to follow this. Okay, why? Because so here z equal to x into y. Okay, if we differentiate on both sides, differentiating on both sides, then what we get? Differentiating on both sides, or otherwise, okay, delta z. So what about z differentiation is delta z, correct? X into delta y plus y into delta x. we applied multiplication rule, x into delta y plus y into delta x. So we are dividing with a z on both sides. Then by simplifying, we get this formula. So in the case of multiplication principle, in division principle, so we have to follow 5%. Okay.
Okay, sir.
And even though if we are following the power, for example, x square, x cube, so in power also we have to follow the limit, error limit we have to follow. Okay, in multiplication, division, and power.
So in the formula you've written delta z is delta x plus delta y. When do we have to use that one?
To find a maximum percentage, to find maximum error in subtraction case.
Okay, sir.
Okay, for example, here I'm taking, for example, it is a substance. For this substance, mass is given 10 gram plus minus 0.1 gram, the total mass of the substance. Total mass of the substance. Okay, from this substance, so we are removing some mass. We are removing some mass. So how much mass we removed is 5 gram mass we removed plus minus 0.1 gram. Then how to find remaining mass? How to find remaining mass? This remaining mass we have to find in the form of like x plus minus delta x. In this form, I want to find out remaining mass. First of all, total mass 10 gram. Okay, removing mass 5 gram. So how much mass of the gram is remaining here? Total mass 10 gram, removing mass 5 gram. So how much mass is remained?
5 gram.
5 gram plus minus. No, I want to find this error. To find error, so here remaining means we have to do addition or subtraction. Remaining means subtraction. So 10 minus 5 is a 5. But errors can be subtracted or errors are always added.
Always added.
Always
So,
added, sir.
according to this formula. Okay, errors always added. So 0.1, 0.1. So total it is 0.2 grams. Like this. Okay. So always we have to find a maximum error means error should be added. Even though it is addition or subtraction, we have to add errors. Okay, so you please let me know Vernier calipers screw gauge completed in your regular classes with the numericals.
No, sir.
No, sir.
That means you know equations, how to find readings by using Vernier calipers screw gauge.
No, sir.
No. Okay. So finding least count, you have any basic idea finding least count?
Yes, sir.
Yes, sir.
Okay, then take the break for 15 minutes, then we continue. Okay.
Okay, sir.
Okay.
So you are ending the meeting.
No, so I'll keep running. Okay.
Or finding error, finding readings, diameter of small spherical or cylindrical bodies, So third one is to measure inner diameter, of hollow cylinder. Inner diameter of hollow cylinder. Okay. So in the case of Vernier calipers, so we know it is a main scale. Just a minute. Okay. So in vernier calipers, this horizontal is the main scale. It is main scale and it is vernier scale. Okay, it is main scale, it is vernier scale. A and B are two jaws. So A and B are jaws. Now in between them, we have to keep the body. And C and D, C and D, so to measure inner diameter. So CD also jaws, but CD jaws we have to use to measure inner diameter of the cylinder. And we have this is a metallic strip, okay, something like a rod type. So it is a rod. So this rod is used to find depth, depth of the beaker or height of the water column. So that is E. Okay, so A and B are the two jaws and C and D are the jaws. So we can find, so by using C and D, we can find the inner diameter of the cylinder, and by using E strip, we can find out so depth of the beaker or any height of the water column. So those things we can find out. Okay, so it is a main scale. So and it is a vernier scale. So generally main scale is in centimeters. Main scale is in centimeters. Okay, that means what is the smallest division on main scale?
0.1 centimeter.
So 0.1 centimeter is the smallest division on the main scale. So that is 0.1 centimeter. So generally, in general, so the vernier calipers will be like this. Listen, if it is a main scale, it is a main scale, MS, simply main scale, it is 0 division. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, that means it is 1 centimeter. It is main scale. And for example, here it is vernier scale. It is vernier scale. And for example, so on vernier scale, totally we have 10 divisions will be present. On vernier scale, 10 divisions are present. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so these are the divisions on vernier scale. Okay, so 0 division, then 1, 2, 3, 4, totally 10 divisions are present. Okay, so now what is, so in this case, see here, from 0 to 1 centimeter, 10 divisions. Okay, and from 0 to 10 also, here we have 10 divisions. Okay, that means here in the case of main scale, in the case of vernier scale, so which division is slightly greater? Main scale divisions are slightly greater or vernier scale divisions are slightly greater?
Main scale, sir.
Okay, main scale divisions are slightly greater. Okay, so for example, in the case of main scale, for example, I'm taking, it is main scale, it is main scale, it is A. This A means one division. Okay, so this one division I'm taking as A. And in the case of vernier scale, so it is one division. Okay, so one division in main scale. So here between them, so between these two divisions, what is the separation? Okay, that is, let it be A. Then after, in the case of vernier scale, so it is longer or shorter one? As compared to shorter one. So it is, in the case of vernier scale, the separation between two divisions. So here between them, what is the separation? That is B. So it is A. So that means here, no, it is A, okay, one division length. It is B, one division length in vernier scale. So by using vernier calipers, what is the smallest measurement we can measure? By using vernier calipers, what is the smallest division we can measure? A or B or A plus B or A minus B? So by using vernier calipers, this separation is the smallest division.
A minus B.
So this is a C. So by using vernier calipers, so it is, so the separation between two divisions on main scale and separation between two divisions on the Vernier scale. And so both this separation and this separation will be different. So between two divisions, separation A on the main scale, between two divisions, separation is B on the Vernier scale, and what is the slight separation between them is a C. So C is the smallest measurement we can measure by using Vernier calipers. So what is the definition of least count? Least count means the smallest measurement we can measure by using an instrument is the meaning of least count. The smallest measurement is the least count. So therefore, for Vernier calipers, what is the least count is A or B or A minus B?
A minus B.
So A minus B is the smallest measurement. So therefore, least count of Vernier calipers is A minus B. And what is the meaning of A? One division on the main scale, correct? A means one division length on main scale. So in the place of A, I'm writing one main scale division minus, and what is the meaning of B here? One division on
Vernier scale division.
So it is one Vernier scale division. So this is the formula to find least count. So for example, in the question, if it is given that m divisions on main scale, and I have one more question. What is the value of one main scale division? On the main scale, what is the division? What is the one division value?
0.1.
0.1 centimeter. So it is one main scale division, so generally 0.1 centimeter. Then after, so for example, the questions will be given like this: m divisions on the main scale is equal to n divisions on Vernier scale. N divisions on Vernier scale. So for example, this logic, if we apply over here, so what about 9 divisions on main scale is equal to 9 divisions on main scale is equal to 10 divisions on the Vernier scale or not?
Yes, sir.
So it is up to 9 divisions on the main scale. Okay, so 9 divisions on the main scale is equal to 10 divisions on the Vernier scale. Okay, so like this, I'm giving one general statement. So m divisions on the main scale coincides with n divisions on the Vernier scale. Okay, so m and n can be anything that will be given in the question. Okay, so that means here m divisions on the main scale is equal to n divisions on the Vernier scale. From this equation, what is the value of one Vernier scale division equal to? We get m upon n main scale division. Therefore, by taking this equation in this formula, then what is the one more alternative formula to find a least count? Is equal to 1 MSD I'm writing as it is. So what is the basic formula? 1 MSD minus 1 VSD. So least count of Vernier calipers equal to 1 MSD minus, so in the place of 1 VSD, I'm writing m upon n MSD. Therefore, least count equal to, so take the common of 1 MSD. If 1 MSD is the common, now in brackets, what we get? 1 minus m upon n. So it is one more alternative formula to find least count of Vernier calipers. And what is the meaning of m? Number of divisions on main scale. M means number of divisions on main scale. And what is the meaning of n? Number of divisions on Vernier scale. Number of divisions on Vernier scale. Now this is the formula to find least count. Now write down the question.
So
Please.
why is least count equal to A minus B? Can you explain that again?
So generally, what is the meaning of least count? The smallest measurement we can measure. The smallest measurement we can measure is the least count. So it is A means the separation between two divisions on the main scale. and B means separation between two divisions on the Vernier scale. Okay, so A on the main scale, B on the Vernier scale, but by using this whole Vernier calipers. So by using this whole Vernier calipers, what is the smallest measurement we can measure is, see here, focus on this. For example, it is division on the main scale. Then after, it is division on the Vernier scale. So between this main scale division, this main scale division, this Vernier scale division, so between them there is a small separation is present or not?
Yes, sir.
Now this is the meaning of least count. So this is smallest measurement we can measure by using Vernier calipers.
Okay, sir.
Okay, so it is the smallest measurement, that is numerically C over here. Okay. Now C is the smallest measurement we can measure by using Vernier calipers. Okay. Is it clear now?
Yes, sir.
Okay. So write down the question. In Vernier calipers, main scale is marked in millimeter, and 20 Vernier scale division are equal to 16 main scale division. Find least count. So this question was given in 2010. In Vernier calipers, main scale is marked in millimeters. Okay, that means what is the value of 1 MSD? What is the value of each division on the main scale? What is the value of each division on the main scale? 1 millimeter, correct? For example, in main scale 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is 0 centimeter, 1 centimeter. So what is the value of each division? Each division is 1 millimeter or 0.1 centimeter. Both are same. 1 millimeter or 0.1 centimeter. So 0 millimeter, 1 millimeter, 2 millimeter, 3 millimeter, 9 millimeter, 10 millimeter. So 10 millimeter is nothing but 1 centimeter. So what is each division value on the main scale is 1 millimeter, because specifically they have given in millimeters. So we have to write in millimeters. So each division value on the main scale is 1 millimeter. Now I want to find the least count. So what is the formula to find the least count? Already we have 1 MSD in bracket 1 minus m upon n. From this equation, 1 MSD into 1 minus what I told, m means number of divisions on
Vernier.
m means
Main scale.
main scale. On main scale, how many divisions are given?
16 upon 20.
Perfect. 16 upon 20. So it is nothing but 4 upon 20.
1 by 5.
Correct. So 4 by 20 into 1 MSD. But we know already 1 MSD value. So it is 1 by 5 into 1 milli. So therefore answer is 0.2. So 0.2 millimeter is the least count. You write down one question as a homework. So this question is given in JEE 2003. N divisions.
Sir,
Please.
you'll be sending this recording on the group, right?
Yes, I will send you. Recording plus notes, both I will share. Okay.
Okay.
N divisions of main scale.
Sir,
Please.
sir, such types of direct questions are only asked. No?
In mains examination, only this type of question they're asking. So if it is advanced also, I will do 1 or 2 questions. Okay. In advanced level, I will do 1 or 2 questions, both. N divisions of main scale are equal to n plus 1 divisions of Vernier scale. If each division on main scale is small a units, find least count. Okay, that means what is the value of 1 MSD, what they have given in the question? 1 MSD value. A. No, I don't know, you try it. Okay, so we have n divisions on the main scale, n plus 1 divisions on the main scale. Already we have the basic formula to find a least count. You try to do it. Okay.
Sir, A upon n plus 1.
Correct. Write down. Next, reading of Vernier calipers. Reading of Vernier calipers. Well, that means how to find length of an object by using Vernier calipers. Okay. Okay, listen. So I will draw one figure. Okay. So for example, here AB is a rod. AB is a rod. Now I want to find out. So the length AB I want to find out. With this length AB I want to find out. You please answer. This length AB is exactly equal to 1 centimeter. This length AB exactly equal to 1 centimeter.
No, sir.
Or exactly equal to 1.1 centimeter.
No, sir.
No. Okay, that means here what is the reading AB? It is in between 1 centimeter and 1.1 centimeter. Okay, not exactly 1 centimeter, not exactly 1.1 centimeter. So I want to measure the accurate length. The accurate length AB I want to find out. Okay, write down the formula. Total reading equal to MSR, means main scale reading. MSR plus n into least count. Okay, I will explain what is the meaning of MSR and what is the meaning of n. And you know already how to find the least count. Okay, we have already the formula least count 1 MSD into 1 minus m by n. So we know the process to find least count. Okay, so what is the meaning of MSR? Means main scale reading. So it means that MSR, it is nothing but main scale reading on the left side of 0 division of Vernier scale. So here it is a 0 division. It is 0 division in the Vernier scale. For this 0 division on the left side, so which reading is present? 1, correct? So 1 centimeter or 1 millimeter it is? Centimeter. So that is MSR. What is the meaning of MSR? Main scale. So on the main scale, left side of 0 division. So which reading is present? That is MSR. Left side of 0 division on the Vernier scale. So this reading is the main scale reading. And what is the meaning of N? This N means the number of Vernier scale which coincides with any one of division on main scale. the number, so that is the first division of Vernier scale, second division of Vernier scale, that number we want. The number of Vernier scale which coincides with any one of the division on the main scale. See here, in this case, all these are the Vernier scale divisions. All these are Vernier scale divisions. So which number is exactly coincides with main scale?
5.
5.
Fifth.
See here, exactly fifth division on the Vernier scale. Fifth division on the Vernier scale exactly coincides with main scale. So that is the n value. Okay. So which is coinciding, that number is n. So therefore, in this figure, what is the total reading equal to? So we have already the formula MSR plus n into least count. So what is the MSR value? MSR 1 centimeter. So what is the meaning of MSR? Left side of 0 division. Left side of 0 division, we have 1 centimeter is present. So it is MSR plus, in the place of n, what we can write? Which division is coinciding with the main scale? Fifth one. And what is the least count of Vernier calipers? In this case, so totally how many divisions on the main scale? Between 0 and 1. So between 0 and 1. Okay. See, what is the least count of Vernier calipers? Generally, what is the value we have? 0.1 centimeter. What is the exact value of least count of Vernier calipers? 0.1 centimeter or 0.01 centimeter?
0.01.
0.01 centimeter. But how to get 0.01 centimeter? Anyone?
Through that formula which we derived
Correct.
earlier.
So from this equation. Okay. So least count is 0.01 centimeter. 0.01 centimeter. Therefore, by simplifying, we get 1.05 centimeter is length of AB. Okay, not exactly 1 centimeter, not exactly 1.1 centimeter, anywhere in between. So 1.05 centimeter. Okay, so I will do one question.
Sir,
Please.
Sir, the least count which we took as 0.01 centimeter, did we use that least count formula to arrive at it, or did we just?
No, I will do one question. In the question, it will be mentioned how to find a least count. Okay. So generally, for Vernier calipers, least count is 0.01 centimeter in general. Okay, maybe one hypothetical cases will be given in the numericals. Okay, but how to find a least count? Okay, I will do one question. See, in the question, it will be very clear to you.
So, sir, if nothing about least count is mentioned, then we take it as 0.01.
0.01.
And if something is mentioned, then we use that formula to calculate the least count.
Correct.
Yes.
Now write down the question. In Vernier calipers, write down the question. In Vernier calipers, 10 Vernier scale division equal to 9 main scale division. Okay, that means from this, what we can find out? So can we find least count or not?
Yes, sir.
Yes, sir.
This is M value. Okay, M means number of divisions on the main scale, and it is N value, number of divisions on the Vernier scale. Okay, and 1 centimeter on main scale is divided into 10 equal parts. Divided into 10 equal parts. Okay, that means what is the value of each part, each division on the main scale?
0.1 centimeter.
0.1 centimeter. That is 1 MSD. Okay, 1 MSD is 0.1 centimeter. While measuring length of a rod, so here, right, while measuring length of a rod, the zero division of Vernier scale is just ahead of 1.8 centimeter mark. Just ahead of 1.8 centimeter mark. Now, what is the meaning of 1.8 centimeter? Which reading it is?
Main scale reading.
So correct, MSR. And fourth division of fourth division of Vernier scale coincides with main scale division. Coincides with main scale division. Find length of the rod. Find length of the rod. Find length of the rod. So first of all, we have to find the least count. How to find least count? 1 MSD into 1 minus m upon n. So in the question, 1 centimeter on the main scale divided into 10 equal parts. Okay, that means what is the value of each part on the main scale? 0.1 centimeter. It is 0.1 centimeter in bracket. So according to question, how many divisions on the main scale?
9 by 10.
9 by 10. So it is 9 upon 10. So by simplifying, we get 0.01. 0.01 centimeter is a least count. Now I want to find total reading. So total reading is length of the rod only. So total reading equal to MSR plus n into least count. What is the MSR according to question? 1.8 centimeter. And which division is coinciding? 4 into least count is 0.01 centimeter. Therefore, it is so 1.84 or 1.804.
84.
8. Done.
Yes, sir.
Could you please repeat what is N?
N means which division of Vernier scale coincides with main scale. You refer the figure. In this figure, which division of Vernier scale coincides
sir,
with
got it,
main
it's fine.
scale? So it is
Fifth
5. It is fifth one, that 5. For example, if 4 is coinciding 4, if 9 is coinciding 9, in that way. Okay.
Understood, sir.
Write down. Next question. So this question is given in 2013. Diameter of a cylinder diameter of a cylinder is measured using Vernier calipers with no zero error. So I will explain what is the meaning of zero error also in the next concept. Okay, so here no error is given. It is found that the zero of Vernier scale lies between 5.10 centimeter and 5.15 centimeter. 5.10 centimeter, 5.15 centimeter of the main scale. The Vernier scale has 50 divisions, which is equivalent to 2.45 centimeter is equivalent to 2.45 centimeter. 24th division of Vernier scale 24th division of Vernier scale coincides with main scale. Coincides with main scale. Coincides with main scale. Find diameter. Find diameter of cylinder. Find diameter of cylinder. So in the question, for example, if it is a main scale, on the main scale, this reading is 5.10 centimeter and this reading is 5.15 centimeter, and between them we have 0 reading of Vernier scale is present. Okay, 0 reading of Vernier scale is present. So it is a 0 reading of Vernier scale. Okay, so in the question, 0 reading of Vernier scale lies in between 5.10 centimeter and 5.15 centimeter. Okay, that means from this information, what is the value of 1 MSD? What is the value of 1 MSD? What is the value?
1 mm.
Not 1 mm. So here, for example, in this case, in this figure, so it is 1 centimeter. It is 1 centimeter. It is 1.1 centimeter. It is 1.1 centimeter. So between 1 centimeter, 1.1 centimeter, we have 0 division is present. Between 1 centimeter, 1.1 centimeter, we have 0 division is present. And what is the gap between 1 centimeter and 1.1 centimeter is 0.1 centimeter. So 0.1 centimeter is the MSD, main scale division. Okay, but in our question, in our hypothetical question, this 0 division is present in between 5.10 centimeter and 5.15 centimeter. That means what is the main scale division is equal to?
0.01.
0.01 or 0.05?
0.05.
0.05. Okay, so 1 MSD equal to 0.05 centimeter. Okay, see in this question, in this figure, so this 0 division is present between 1 centimeter, 1.1 centimeter. So between them, 0 division is present. And what is the value of 1 MSD? Now this separation. This separation is 0.1 centimeter. So 0.1 centimeter is a MSD, main scale division. If the same logic you apply in our question, now this division is 5.10 centimeter. This division is 5.15 centimeter. Between them, 0 division is present. Okay, that means what is the value of this main scale division in our question?
0.05.
So 0.05 centimeter. So that is one main scale division. Then after in the question, 50 Vernier scale divisions. So total we have 50 divisions on the Vernier scale. 50 divisions on the Vernier scale. So 50 Vernier scale divisions is equal to how much length? 50 Vernier scale divisions is equal to 2.45 centimeter. 2.45 centimeter. From this equation, what is the value of one Vernier scale division equal to 2.45 upon 50 centimeter? Now we have one MSD value and we have one VSD value. Then how to find least count is 1 MSD minus 1 VSD. So we have MSD value and we have VSD value. So we can find out least count. After finding least count, then how to find the total reading is total reading equal to what is the basic formula we have? MSR plus N into
total
least count. And what is the MSR means? Left side of 0 division. So which reading is present?
5.1.
So 5.1. So it is 5.10 centimeter is the main scale reading. And in the question, so which division of Vernier scale is coinciding?
24th.
24th. So this N value 24 into least count. First of all, you do this is simplification. This is simplification. Find the least count.
0.001.
So 0.001.
001.
This is 0.001 centimeter. So this least count you write down over here and simplify and find out diameter of the cylinder.
5.076.
5.076. How? It is 5.10 centimeter.
Sir, 5.124.
5.124. It is 24 into 0.001 centimeter. By simplifying, we get 5.124 centimeter. Over.
Sir,
Please.
in the question there was this phrase zero error or something. Could you explain that?
I will do it in the after next question.
Okay,
Okay, so we have positive zero error, negative zero error. So we have two types of errors are present. Okay, that also I will discuss. Okay. Okay, see the question. So this question was given in advanced 2016. So total we have two Vernier scales are given, C1 and C2. Okay, two Vernier calipers. C1 is the first Vernier calipers and C2 is the second Vernier calipers. So in the case of C1, what information we have given? 10 equal divisions correspond to 9 main scale divisions. So on the Vernier scale of C1, 10 divisions correspond to 9 main scale divisions. Okay, that means in the case of C1, what we have given, 9 divisions on the main scale is equal to how many divisions on the Vernier scale?
10.
10. Then after, so you refer the figure, it is given 1 centimeter dividing into 10 equal parts. Okay, 1 centimeter dividing into 10 equal parts. Okay, that means what is the value of 1 MSD?
0.1.
0.1 centimeter. Now, how to find least count of first Vernier calipers? Least count is 1 MSD into 1 minus M upon N. Correct? Therefore, from this least count equal to what is 1 MSD value? We have 0.1 centimeter
Into 0.1.
Correct, 0.1. Therefore, it is 0.01 centimeter. Now, what is the reading of C1? That reading I want to find out. Okay, I want to find reading. So what is the basic procedure? How to find reading? MSR plus N into LC. Okay, so I will zoom it. Is it visible clearly, the figure?
Yes, sir.
Okay, so for zero reading left side, for zero reading of Vernier scale left side, so which scale present on the main scale?
2.8.
Perfect, 2.8. Then after, which division is coinciding?
7th.
Okay, see clearly here, seventh division is coinciding. Seventh one is coinciding. Is it clear?
Yes, sir.
Okay, therefore I am finding a C1 means reading of the first Vernier calipers. MSR, what is the MSR? Please.
So can you repeat the last part? How did you get us 2.8 and 7?
So for zero reading of Vernier calipers, left side of zero reading, so which reading is present on the main scale? It is 2, it is 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, 2.7. It is 2.8, correct? See here, zero division. For zero division left side, so which reading is present on the main scale? 2.7 or 2.8? 2.8. Okay. So Main scale reading is a 2.8 centimeter plus n into least count. N means which division is coinciding?
7 into
Seventh one.
0.01.
So this seventh division is coinciding. Okay, so 7 into 0.01. 7 into 0.01. Therefore, by simplifying, what we get 2.87 centimeter. 2.87 centimeter. Is it clear?
Yes, sir.
Okay. So coming to C2. Now second Vernier calipers. In C2, so which information we have given on the Vernier scale? 10 divisions corresponded to 11 main scale divisions. Correct? On Vernier scale, 10 divisions correspond to 11 main scale divisions. Okay, that means in second Vernier calipers, 10 divisions on the Vernier scale is equal to 11 divisions on the main scale. Okay, then after, and what is the MSD value here also? What is the MSD value? 0.1 centimeter, correct? This 1 centimeter totally we divided into 10 equal parts. This 1 centimeter gap we divided into 10 equal parts. So what is the MSD main scale division is? So 0.1 centimeter. 1 MSD equal to 0.1 centimeter. Then what is the value of least count you are getting, positive or negative?
Negative.
Negative.
So negative least count practically possible or not possible? Not possible. Least count means the smallest measurement we can measure. The smallest measurement we can measure. So negative measurement is practically possible.
No.
No.
So that means here in the case of C2 Vernier calipers, this formula is not applicable. Finding least count formula is not applicable. So why? Because so generally in the case of Vernier scale, which scale is smaller? Main scale readings are smaller or Vernier
Vernier
scale?
scale.
Okay, but in the case of C2, in the case of C2, so whose divisions are smaller?
Main scale.
Main scale divisions are smaller. Main scale divisions are smaller. Okay, so the regular procedure is not applicable in this case. Then how to find the reading? Okay, is it clear? First of all, is it clear?
Yes.
Yes, sir.
So here we are getting negative least count, practically not possible. Then how to measure the reading? See, in this case, it is 0 centimeter, correct? 0 centimeter. Left side, what we have?
2.7.
2.7, 2.8,
2.88.
2.8. Okay. So the same figure I'm drawing in the bigger view. For example, here, it is a main scale. It is a main scale, and this is 2.8 centimeter. 2.8 centimeter, and here we have 0 division of Vernier scale is present. 0 division. Okay, just a minute, please. For example, it is 0 division of Vernier scale. So what is the MSR value? MSR value 2.8 centimeter, correct? 2.8 centimeter, correct?
Yes, sir.
So what is the total reading is? Total reading is 2.8. For example, this length is I'm taking, let it be x. Now what is the reading of the Vernier calipers? 2.8 plus x or 2.8 minus x?
Plus X.
Plus x. 2.8 centimeter plus x. But how to find x value? How to find x value? Okay, so again going to question. For 0 scale, 0 Vernier scale, left side we have 2.8 centimeters. So it is 2.8 centimeter. It is 2.8 centimeter. Okay. Then after, so which Vernier scale coincides with the main scale? Which Vernier scale coincides? 7th. See, seventh one is coinciding. Seventh one is coinciding, correct?
Yes, sir.
This seventh one is coinciding. Okay, so here this is seventh division on the Vernier scale. It is coinciding with main scale, coinciding with main scale. So between 0 Vernier scale, 7th Vernier scale, what is the total gap? It is 6 VSD or 7 VSD. This gap is 7
7 VSD.
VSD. Okay, but the target is we have to find X value. Now already here we have, this is 7 VSD, 7 VSD. Then after it is 2.8 centimeter. Then after this 7 centimeter, this 7 centimeter. Okay, so if we know, for example, already here it is 7 VSD. If we able to calculate this length, so for example here this length, then how to measure this X value is
Length minus 7 VSD.
okay, got it now? This length minus 7 VSD, so we can find out X value. Are you getting the point? Is it clear?
Yes, sir.
Yes, sir.
Okay, then after, so it is 7 VSD, this length is 7 VSD. Okay, so for example here in this case, seventh Vernier scale is coinciding, so it is totally 7 VSD. Okay, so you please answer, what about this reading is, this reading is so how much it is? 3 point what? 3 point what?
6.
3.6 na? 3.1, 3.2, 3.3, it is 3.5, it is 3.6. Okay, it is 3.6. It is 3.6 centimeter, correct? Therefore, now in this case, so it is 2.8 centimeter, 3.6 centimeter. Now what is the total length? It is, what is the total length?
0.8.
0.8.
In 0.8 centimeter, in 0.8 centimeter. So what are the values are included in this 0.8 centimeter? This X value present and 7 VSD also present, correct? In 0.8 centimeter length, X value present, 7 VSD also present. X value present and 7 VSD also present. But we have to find the X value. We have to find the X value. Okay, then how to find the VSD? To find the VSD, again go back to the question. In question what we have given, 10 Vernier scale divisions coincides with 11 main scale divisions. From this equation, what is the value of one Vernier scale division is equal to what we get? 11 upon 10.
0.11.
So main scale division, so 11 upon 10. So what is the one main scale division is 0.1 centimeter. Okay, so therefore by simplifying we get 0.11 centimeter. Therefore 0.8 centimeter equal to X plus 7 into 1 Vernier scale division is 0.11 centimeter. 0.11 centimeter. So it is 0.8 centimeter minus 0.77 centimeter is equal to X. Therefore, what is the X value? 0.3 or 0.03? 0. So therefore, so what is the total reading is 2.8 centimeter plus X, and we have X value. Therefore, what is the total reading on second Vernier calipers? C2 equal to 2.8 centimeter plus 0.03 centimeter. The total is 2.83 centimeter. Okay, process is clear. If least count is getting negative, the process is clear how to find X value.
Yes, sir.
Okay.
Yes, sir.
Please.
Sir, I'm having a doubt regarding main
Please.
scale. Sir,
Please.
you have to find X. We calculated by adding X plus 7 VSD and we
Correct.
got that 0.8.
0.8, correct.
But sir, on the main scale there are 11 divisions. So will that match with the original main scale?
See, generally here we are taking the separation now. See, observe clearly here. In this case, this reading is equal to, it is 2.8 centimeter, correct? It is 2.8 centimeter, and this is 3.6 centimeter. Okay, so here this information is only applicable to find least count information. 10 Vernier scale divisions is equal to, okay, that means here, for example, if I take it is 0 Vernier scale division, it is a 10th Vernier scale division. So total we have 10 divisions on the Vernier scale are present. So in this 10 divisions space, so how many main scale divisions are present? How many main scale 11 are present. So it is 0 of main scale and it is 11th of main scale. Okay, so here, so this information, it is only, what is the conclusion here? The main scale is smaller than Vernier scale. This main scale smaller than Vernier scale. But what is the gap it is? Even though, so here, for example, it is 0 centimeter, it is a 10, and this is 11. From 0 to 10 centimeter means how much gap it is?
1 centimeter.
1 centimeter. The next one is, it is giving 1.1.
1.1, yeah.
Okay, but this gap from 0 centimeter to 10 centimeter, it changes, it will be same.
It's same.
It will be
Yes,
same.
got it.
Okay. Okay, any doubt in this question? Okay, now listen, we have 0 error right now. I think you got assignment of P1 and P2. So in those assignments, we have some questions depends upon errors also. So what is the meaning of 0 error and what is the meaning of no 0 error? Okay, so for example, I will show you the first figure of Vernier calipers. In this figure, so what there is no 0 error means, listen, there is no 0 error means 0 division of main scale and 0 division of Vernier scale if exactly they match, they coincide. Okay, that means we can say that the instrument has no error. Okay, so 0 division of main scale, 0 division of Vernier scale. So before starting experiment only we have to do it. Okay, before starting experiment, first we have to find 0 error. Okay, not in the running of the experiment. Before starting experiment we have to find error. Okay, so before starting experiment you verify it. So 0 division on the main scale, 0 division on the Vernier scale, if they coincide, we can say no 0 error is present. No 0 error is present. And we have two types of 0 error. We have two types of 0 error. So first one is positive 0 error, positive 0 error, and second one is negative 0 error. So no 0 error means, so both 0 division exactly if they coincide, the instrument has no error. Okay, now what is the meaning of positive 0 error and negative 0 error? Okay, is it visible, the figure?
Yes, sir.
Yes, sir.
So here No zero error means, see the first figure, see this figure, 0 0 exactly matching, 0 0 exactly matching, so no zero error. But you refer this figure and this figure. In this case, what is the zero reading of Vernier scale? Zero reading of Vernier scale on the right side of zero division of main scale, correct?
Yes, sir.
Okay, so it is a positive error. So what is the meaning of positive error? If zero Vernier scale division is on the right side, of zero division of main scale. So that is the meaning of positive error. Okay, write down positive error. Okay, in brief, positive zero error. Positive zero error. Zero of Vernier scale is on right side of zero of main scale. For example, here it is main scale 0, and for example it is 1 centimeter, and total we have 10 divisions. So 1 2 3 4 5 6 7 8 9 10. So 0 and 1 centimeter, it is a main scale. On the Vernier scale, it is 0. So 1 2 3 4 5 6 7 8 9 10. For example, something like this. It is a Vernier scale. Now here it is a positive error or negative error.
Positive.
Positive.
How we come to know positive error? So simply here you focus on zero division of Vernier scale. So you focus on zero division of Vernier scale where it is on the right side. On the right side is a positive, left side is negative. Okay, on the right side of zero of main scale, so it is a positive error. So therefore, now I want to find out this positive zero error. I want to find a positive zero error equal to, the formula is n plus x into least count. Positive zero error, n plus x into least count. So what is the exact meaning of n? N is nothing but main scale reading on the left side of zero of Vernier scale. So in this case, for zero of Vernier scale left side, which main scale reading is present?
0.
0. Okay, so it is, this value is 0. For example, in the question, it is a main scale 0 and it is 1 centimeter, and we have total 10 divisions are present, 1 2 3, so something like this, 10 divisions are present. For example, here it is a zero division of Vernier scale. Okay, now for this zero division of Vernier scale, left side which reading is present on the main scale, 0 centimeter or 0.1 centimeter?
0.1.
0.1 centimeter. So this n means main scale reading on the left side of zero of Vernier scale. So now in this question, what is the n value is?
0.
0 plus, and what x means, which division is coinciding? X means which division is coinciding. So which division is coinciding here? For example, it is coinciding. It is 6, correct? It is 6. So x value is 6. Generally, what is the least count of Vernier calipers? That can be find out by use, for example, in the question, if it is given something like this. So 10 VSD is equal to 9 MSD. Something, the information will be given. Accordingly, we can find out the least count. So generally, I'm taking 0.01 centimeter. In general, so this is the least count of Vernier calipers. Therefore, what is a positive zero error we got? Plus 0.06 centimeter plus 0.06 centimeter. Now, what is the total reading value now? Total reading, or we can say correct reading. Correct reading equal to total reading. So how to find total reading? How to find total reading in the case of Vernier calipers? Total reading MSR plus n into least count. So that is the total reading. So always we have to follow minus zero error we have to write. So it is a basic formula. So how to find the correct reading is total reading minus zero error. This zero error may be positive zero error or negative zero error. Therefore, correct reading is equal to total reading minus, if it is a positive, so we have to follow positive zero error. Okay, this minus is a common, this minus is common. If it is a positive zero error, so take positive, so positive zero error. If it is a negative zero error, you take minus means negative zero error. In the case of negative zero error, this minus is common, minus, but this also minus. In the case of negative zero error, minus into minus becomes plus, correct? But why to subtract? Why to subtract positive zero error from the total reading?
Since we are ahead of main scale.
Perfect. We are ahead of main scale. Okay. Write down straight away in the case of negative error. So what is the meaning of negative error? First of all, what is the meaning of negative zero error? Zero of Vernier scale, zero of Vernier scale on left side, on right side?
Left side.
Left.
On left side of zero of main scale. Zero of main scale. Okay, for example, you refer this figure. Okay, so it is zero division on the Vernier scale. So for the main scale, so here this zero division of Vernier scale is on the left side, on the left side of zero of main scale. Then how to find total, how to find correct reading is total reading minus zero error. So correct reading equal to total reading minus negative zero error. Negative zero error. So this minus into minus becomes plus. Okay. Okay, same thing. I have very small shortage of time. So depending upon errors, I will send you some practice questions in the group. So you please go through it. Okay.
Okay, sir.
Yeah. And do you know screw gauge?
So in this question, how do we have to find zero error?
Same formula. Same formula. Okay.
Okay.
So, but in the place of plus, what we get? First, you find out this value as it is. After finding this value, you add plus or minus depending upon the error. Okay. So
But
this
how
will
do we
be
take n, capital N?
so generally capital N value will be zero, na? In this case, so in the case of negative error, so for example, it is zero reading and it is 1 centimeter reading and it is Vernier scale. Vernier scale 0 and for example it is 10. Okay, so in this case, see here, no, left side nothing is present. Left side nothing is present. No, on right side, which division is present on the main scale on the right side?
0.
0. Okay. So in the case of positive error, see left side. Left side, which error is present? In the case of negative error, so which reading is present on the right hand side? Why? Because left hand side nothing is present. So see right hand side, which error, which reading is present? That is n value. That is n value. Clear?
Okay, sir.
Yeah.
So
So
in
you apply. Please.
so in negative zero error, the value of n will always be 0, right?
Ah. So you find out this value as it is. Find this value. Find this value. So depending upon error, if it is a positive error, take positive. If it is negative error, take negative. Okay, like this. Okay, do you know screw gauge?
No, sir.
No? Okay. Write down so.
Sir, till what time class is there?
So I think my maximum I try to complete within 15 minutes. Okay. Why? Because I have also one more lecture. Then what we can do, so we have we left with the semiconductors, optical instruments, EM waves. So what we can do it.
So in the evening,
No, I have lectures. So I have 2 more lectures. That's why.
so we don't have lecture tomorrow.
But I have busy schedule. That's why. So I will
Sir,
do
you
one
can
thing.
share questions and we'll try them and we can ask
That all I want to say. So I will share the questions. You please go through the why, because per each topic, like what we had done per each model, I try to complete 2-3 questions. In the same way, for each and every concept, I have the questions. Okay. So for example, I will show you. Okay, just a minute. I will show you like this. So for example, depending upon P1 concept, so we have units and dimensions, error analysis, semiconductors, regarding Vernier calipers, some questions, screw gauge, some questions. In the same way, depending upon P2, so we have optical instruments. Okay, depending upon microscopes, I have some questions. Okay, some questions. In the same way, depending upon telescope, I have some questions. Like the same thing in the case of EM waves, I have some questions. So total 4 questions plus from HC Verma I have 5 questions to discuss. So approximate 6 to 7 questions I have on EM waves. So I will share all the questions. Okay, you please go through it. Okay, if any question solution is not coming, is not getting, not understanding, you please let me know in the next lecture. So we will discuss.
Sir, and can you send the link for EMWs?
I think I sent to one person now in the break time. I will give my number. Okay, so you please text me personally. I will share it. Okay.
Yes, sir. Please.
Sir,
Please.
usual can you share whatever you have written today and all the questions along with the models?
You want module?
Sorry, so the models and whatever questions you have done today.
All the models I will share.
Fine, sir.
All the models, all the questions I will share it. You please go through them. If any solution is not getting to you, you please let me know in the next lecture. I will do it. Is it clear?
Yes, sir.
Fine, sir.
So why? Because that's why I asked you, screw gauge, Vernier calipers, so that I will skip all the questions.
Surely,
But
sir.
you are saying that you don't know all these concepts. That's why we are discussing in detail. Okay. So why? Because generally here optical instruments, EM waves, semiconductors, those were completed in the classes. So I think at least you have some basic idea. Okay.
Yes,
So by taking the basic knowledge, you try to solve the questions. If not getting, let me know. I will discuss in the next lecture. Okay.
Okay, sir.
surely, sir.
So in the case of screw gauge, Okay. So I hope you know screw gauge. You have seen it in the practical lab. So in the case of screw gauge, now this reading, this scale is pitch scale. Okay, this is a horizontal one. It is pitch scale. So we can say pitch scale. So we have different names. So we can say pitch scale, linear scale, or sleeve sleeve scale. So these are the different names of pitch scale. So this horizontal. So we know main scale in vernier calipers. In the same way, in the place of main scale, over here we have pitch scale. Okay, pitch scale or sleeve scale. And this is okay. We have seen it screw gauge in the practical lab.
Yes.
And it is circular scale. Okay, we can rotate it. It is circular scale. Okay, circular scale, or we can say head scale. Okay, we can say head scale. It is nothing but stud. It is stud, and these are the screw. So one screw, two screw, three screws. All these are the screws. All these are the screws. Okay, so we have some different names. So in examination, in the place of stud also, maybe they can give in anvil. Both are same. Stud or anvil, both are same. So we can say screw or spindle. Screw or spindle. So both are same. Okay, we can say stud or anvil. We can say screw or spindle. Okay, then after. So here, so it is a pitch scale or a sleeve scale. It is circular scale, or we can say head scale. Okay, so in this case, I think we have some basic idea of screw gauge. This circular scale we can rotate, correct? We can rotate. So for example, if I'm rotating in anti-clockwise direction, so this spindle will move towards the stud or move away from the stud.
Away, sir.
Okay, so for example, if I'm rotating in I'm rotating in the clockwise direction and anti-clockwise direction. If I'm rotating in the clockwise direction or anti-clockwise direction, this screw will move. This screw will move along the pitch scale. This screw will move along the pitch scale. So here, initially, before starting experiment, it is a baseline on the pitch scale. So here, you see this is the baseline or reference line. So this baseline of pitch scale, it is circular scale, 0 reading. So it's 0 reading on circular scale. So if they coincide, so here baseline, reference line, and 0 circular scale division. If they coincide, we can say no error is present. Okay, so first of all, I'm starting with no error. Okay, if I'm rotating, so starting from 0, again you rotate it, again coming back to 0. You're rotating. Why? Because it's circular scale, we can rotate it starting from 0. You rotate, again coming back to 0. Okay, that means one rotation is completed, correct? Starting from 0, we are rotating it, again it is coming back to 0. That means one rotation is completed. In one rotation here, okay, so it will move one screw will move in one rotation. So it will move one screw, so maybe towards the stud or away from the stud. If we complete 2 rotations, this screw will move 2 screws. Okay, 2 thread or 2 screws in that way. Okay, so what is the meaning of one screw here? This one screw length is nothing but, so on the pitch scale it is 0. On the pitch scale it is 0. It is 1 centimeter. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, in one rotation from here to here it will move. Okay, the same length on the pitch scale, it comes out this value. In that way they will design the screw gauge. In one rotation, this screw, how much distance traveled, maybe towards the stud or maybe away from the stud, this distance traveled is same as that of distance traveled on the pitch scale. This distance will travel. Now whatever this distance value is, This distance value is
0.1.
so 0.1. It is nothing but pitch. This distance is nothing but pitch. Now, what is the definition of pitch? Distance traveled by the screw. Distance traveled by the screw in one complete rotation. In one complete rotation. So in one complete rotation, so how much distance traveled by the pitch? Okay, so how much distance traveled by the screw is the meaning of pitch. Okay, now this information will be given in the question. Like previous we have so 9 MSD equal to 10 VSD. In the same way, regarding pitch information also will be given in the question. Okay, is it clear? First of all, this point, what is the meaning of pitch?
Yes, sir.
Okay, then how to find the least count? Least count of screw gauge, that is a pitch. So pitch can be find out from this statement. What is the meaning of pitch? Distance traveled in one complete rotation. From this statement, in the numerical, we calculate pitch value. So pitch upon number of circular scale divisions. In the question, it will be given. So 50 divisions on the circular scale or 100 divisions on the circular scale, that will be given in the question. Okay, now this is the formula to find the least count, pitch upon number of divisions on the Vernier scale. Okay, if pitch is okay, generally, so how much distance will travel? So it is 0 centimeter, 0.1 centimeter, 0.2 centimeter, 0.3 centimeter, 1 centimeter. Generally, what is the pitch value is?
0.1 centimeter.
0.1 centimeter. So 0.1 centimeter, or we can say 1 millimeter. If pitch is 0.1 centimeter and 100 divisions are present, 100 divisions are present on the circular scale. On the circular scale, then least count equal to, you please answer. If this statement is given, so how to find the least count of screw gauge? What is the pitch value is 1 millimeter upon, so how many number of divisions on the circular scale is given? 100 divisions. Therefore, by simplifying, we get 0.01 millimeter. Okay, now this type of information will be given in the question to find the least count of screw gauge. Okay, let us try one question. Now see the question. 2 full turns of circular scale of screw gauge cover a distance of 1 millimeter on the pitch scale. So total number of divisions on the circular scale is a 50. Now find least count. So how to find the least count of screw gauge? Pitch upon number of circular scale divisions. But how to define pitch? Pitch is a distance traveled in one complete rotation or 2 complete rotations?
One complete.
One complete rotation. So pitch is defined for one complete rotation. Okay. Now refer the question. In the question, what we have given in 2 full turns. In 2 full turns, how much distance traveled is 1 millimeter. Correct. So in 2 full turns, the distance traveled is 1 millimeter, but pitch is defined for one full turn, one completed turn. So what we get, the value is
0.5 mm.
half millimeter. Therefore, let us find out least count. Now, what is the pitch value is 1 millimeter or half millimeter? Half millimeter. So number of divisions on the circular scale, how many are given in the question? 50. Therefore, by simplifying, what we get, 1 upon 100 millimeter, nothing but 0.01 millimeter. It is least count. Is it clear?
Yes, sir.
Okay. So see one more question, same type. No, refer the question. Least count of main scale of screw gauge 1 millimeter. The minimum number of divisions on the circular scale required to measure 5 micrometer diameter of the wire. Now, what is the pitch value and what is the value of least count? You have to explain. So 1 millimeter is the least count. Now, least count of main scale of screw gauge. Least count of main scale of screw gauge is 1 millimeter. So it is a least count of screw gauge. Yeah, anyone? It is least count of screw gauge. So it is pitch value. It is pitch value. Why? Because so it is the least count on the main scale, on the pitch scale. On the pitch scale, the least value is 1 millimeter. On the main scale, on the pitch scale, okay, the minimum value, the least value is 1 millimeter. So it is a pitch, not least count. Even though in the question least count it is mentioned, but the language is different. The language is different. So it least count of main scale, not for the complete screw gauge, not for the complete screw gauge. It is only for main scale. On the main scale, the least value is 1 millimeter. So it is a pitch. Now I want to measure this much smaller diameter. I want to find out this much smaller diameter. I want to find out by using screw gauge. This much smaller diameter I want to measure by using screw gauge. So this 5 micrometer is the least count. 5 micrometer is the least count. Okay, this much smaller diameter I want to find out by using screw gauge. So least count is 5 micrometer. Therefore, how to find a least count? What is the formula? Is pitch upon number of circular scale divisions. You please do it. Let me know the final answer. Please simplify. Thousand, wrong option.
200.
200. 200 is correct one. This least count is 10 power minus 3. Sorry. Least count is 5 micrometer. So 5 into 10 power minus 6 and pitch value is 10 power minus 3 upon we are finding number of circular scale divisions. So by simplifying we get 200. So 200 circular scale divisions are present.
Sir,
Okay,
in the first line, if least count was given, then what would be the wordings of the question?
So generally if no main scale is given, for example, if it is not given, now least count of screw gauge 1 millimeter. So directly least count is given for screw gauge. Okay. But in this question, least count for the screw gauge it is given, or least count of main scale on the screw gauge it is given in the question. For the main scale, not for the complete screw gauge. Okay. So why? Because for main scale, the reading, for circular scale, the readings are different. Okay, so that's why here least count of main scale of screw gauge. So on the main scale, least quantity is nothing but the smallest value. The smallest value on the main scale is nothing but pitch. Okay, clear?
Okay, sir.
Yes, sir.
So write down fast. Note. So what is the reading of screw gauge? Same like previous, main scale reading plus n into least count. And what is the meaning of main scale reading? Main scale reading, what it means?
Pitch scale.
Or pitch scale. What is the meaning of pitch scale? What is the meaning of pitch scale here? If you observe here, now it is okay. You can see this line. For this line, what is the left side reading is present? For this line, left side reading is a main scale reading. Okay. For example here, so it is a main scale. On the main scale, so it is 0. It is okay. First reading 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is 1 centimeter. So it is a main scale or pitch scale. And for example here, I'm taking it is circular scale. For example, it is circular scale. For this circular scale, you focus on this line. For this line, left side, which reading is present? For this left side, which reading is present? That is MSR. That is main scale reading. Is it clear?
Yes, sir.
Okay, so it is a main scale reading. Then after, so what is the meaning of N? So if this circular scale means we have divisions are present. On circular scale, we have divisions are present. So for the baseline, which division coincides? For this baseline, for this reference line, so which division coincides? Okay, that is the meaning of N value. Okay, so here N is nothing but coinciding division of circular scale with baseline or reference line, whatever. So that is the meaning of N, and we know how to find the least count. So pitch upon number of circular scale divisions. So here it is a meaning of MSR. So in this figure, this reading is MSR. Is it clear?
Yes,
sir.
sir.
You have to try one question then. Okay, see the question. It is given that circular scale has 100 divisions. Now we have to find diameter of the wire. Means reading we have to find out. And this main scale is given in millimeters. Main scale is given in millimeters. So it is 0 millimeter, 1 millimeter, 2 millimeter, 3 millimeter, 4 millimeter, 5 millimeter. Means what is the pitch on the main scale? What is the pitch on the main scale? Yeah, what is the value?
0.1 millimeter.
1 millimeter, na? So 0 millimeter, 1 millimeter, 2 millimeter, 3 millimeter, so 5 millimeter in that way.
Okay, okay, yes.
So the least one is 1 millimeter. 1 millimeter is the pitch, or 0.1 centimeter is a pitch. Then after, so how to find least count is pitch upon number of circular scale divisions. So pitch is 1 millimeter upon, so in the question number of circular scale divisions are given 100. Okay, circular scale divisions are given 100. So 1 millimeter upon 100. Therefore, least count equal to, we get 0.01 millimeter. Now I want reading value. So how to find reading? MSR plus N into least count. What is MSR value? You see the question, you see the figure. What is the
5
MSR
mm.
value? 5 mm. 5 mm plus, so the basic formula is N into least count. So it is 5 mm plus n means which division is coinciding. Which division is coinciding. So here you count properly. In this case, it is 30, correct? 30, 31, 32, 33, 34. Now, which division coincides with baseline?
34.
34. So n value 34. And what is the least count? Already we have 0.01 millimeter. From this equation, 5 millimeter plus 0.34 millimeter. By simplifying, we get 5.34 millimeter. So 5.34 millimeter means in terms of centimeters, how much we get? 0.534 centimeters. So that is reading.
Sir,
So
how did you find MSR?
I told you already. So you focus on this line. You focus for this line left side, which reading is present?
5.
So 5 is the MSR. Okay.
Yes, sir.
Clear? Any doubts?
Sir, pitch is the least, is the smallest length of the
main scale.
Main scale. Okay.
Correct. So why? Because in this question, nothing is given. For example, in 2 complete rotation, 1 millimeter distance traveled, nothing is given. Correct? In previous question, see, in 2 complete rotations here, in 2 full rotations, 1 millimeter distance traveled. So according to statement, so we calculated pitch value. If nothing is given means, in this question, nothing is given means what is the meaning of pitch? Pitch is the smallest value. Okay. If nothing is given, take the smallest value. If any specifically, if any statement is given, according to statement, you calculate pitch value. Okay.
Yes, sir.
So one more question. All right. Okay. Now see the figure. The thimble of screw gauge has 50 divisions. 50 divisions. Okay, that means circular scale divisions are given 50. Spindle advances 1 millimeter. Okay, spindle. You know spindle and stud. Spindle advances 1 millimeter when screw is turned through 2 rotations. Okay, that means here, so by default, we have to take pitch is equal to 1 millimeter, or according to statement, we have to find the pitch value.
According to statement.
So according to statement, we have to find the pitch value. Okay, so in 2 complete rotations, so here this spindle traveled 1 millimeter distance. Spindle traveled 1 millimeter distance. So that means here, what is the meaning of pitch? So pitch we calculate for 2 rotations or for 1 rotation?
One rotation.
For 1 rotation. So in the question, in 2 rotations, how much distance traveled? 1 millimeter. For 1 rotation, what is the distance traveled? Half millimeter. So therefore, what is the pitch value is half millimeter. And what about CSD, number of circular scale divisions, is given 50. Now we have pitch value, we have CSD value. Let us find out least count. Least count equal to pitch upon number of circular scale divisions. Pitch is half millimeter and it is 50. Therefore, we get 0.01 millimeter. So it is a least count. Then after, now refer the question, when the screw gauge is used to measure diameter of a wire, the reading of the sleeve, because sleeve is nothing but main scale. So the reading of the sleeve is 0.5 millimeter. Reading on the thimble is found to 27 division. What is the diameter of the wire? So the main concern is, now you have to explain what is the meaning of this 0.5 millimeter and what is the meaning of this 27 division. What they mean exactly. 0.5 millimeter is what?
Is the main scale reading.
MSR.
Correct, MSR. And this is 27 division is the N value. Okay, it is N value. Therefore, so what is the reading? What is the formula we have? Reading equal to main scale reading plus N into least count. Therefore, what is the main scale reading is given 0.5 millimeter, 0.5 millimeter, and which division is coinciding? Which division is coinciding?
27th.
27. 27. And what is the least count? We have already 0.01 millimeter. So it is nothing but 0.5 millimeter plus 0.27 millimeter, and we get 0.77 millimeter, but options are given in centimeters. So we get 0.077 centimeter. It is about reading.
Sir, what is sleeve?
Sorry.
What is a sleeve?
I told you already now. So see the first figure. This main scale is also nothing but sleeve scale. Correct?
Okay, sir.
This main scale also sleeve scale, and I told you already screw. So also nothing but spindle. So in the course, spindle is advancing 1 millimeter into rotations. It is given. So it is a spindle. It is spindle. Okay. It is sleeve is pitch scale,
Yes.
and it is spindle. Okay. Okay. So I will show you one figure finally. Okay, I have one more lecture. Now, what is the meaning of positive zero error? You please explain. See the figure. So this positive zero error or negative zero error, we have to verify before beginning of the experiment or during experiment, when we have to find zero error.
Before the experiment.
Before experiment.
Before.
So I told you already in the previous point. So for example, it is baseline. It is baseline, and it is circular scale, and it is zero reading of circular scale. Okay, if this zero reading is exactly coincides with the baseline, exactly coinciding with the baseline, we can say no zero error is present. No zero error is present. Now, what is the meaning of positive error? Positive error. So this zero circular scale division is below the zero of main scale or above the zero of main scale? Below. Okay, so that is a positive error. Okay, write down. When zero
It's
of
similar to that in Vernier caliper.
same, like, so for example, in the case of Vernier calipers, so we have taken zero of Vernier scale or zero of main scale.
Main scale.
See, in the case of Vernier calipers, what is the meaning of positive error, negative error? So here we focused on the zero reading of Vernier scale. This zero reading on left side of zero of main scale, okay, on the right side of, so in that way. So for example, it is zero. What is the meaning of positive error? We said zero of Vernier scale. Okay, in the same, in the place of Vernier scale, what we have, main scale or circular scale? In the place of Vernier scale, circular scale. So always we have to see the we don't see the main scale, we see we focus on the Vernier scale or circular scale. So 0 of Vernier scale on the right side, so positive error, and 0 of circular scale, so 0 of this Vernier scale on left side is the negative error. In the same way here, this 0 of circular scale, 0 of circular scale is below the 0 of main scale, 0 of main scale or reference line. Okay, from reference line, this 0 reading is below is the meaning of positive error. Okay, positive error. So what is the meaning of so write down the statement. When 0 of circular scale is below the baseline, so that is positive error, positive 0 error. Okay, positive 0 error. And how to find a positive 0 error? How to find positive 0 error? In simplest way, I'm writing x into least count. And what is the meaning of x? So this above 0, now which division is coinciding with baseline?
3.
Okay, 2 or 3? 2.
2.
Okay, so this x value 2. And we know how to find the least count, pitch upon number of circular scale divisions. So we know the process how to find the least count. Okay, now this is the formula to find the positive 0 error. So positive means with respect to baseline, this 0 reading is present below is a positive error. Okay, then after, what is the meaning of negative error? Above. So see here, now what is the meaning of negative error? With respect to base, okay, this 0 reading is above, correct? Okay, so just one imagination. For example, it is the pitch scale, and for example here it is the circular scale. If circular scale I'm rotating in clockwise direction, then now this will advance in the forward direction, this will advance in the backward direction. Forward direction. This will advance in the forward direction. So if it is advancing in the forward direction, so here on the pitch scale, what are the divisions are present? Those divisions are hiding. So below the circular scale or not?
Yes, sir.
Okay, so for example, if I'm rotating in the anti-clockwise direction, now this circular scale will advance forward or backward?
Backward.
So when so if it is moving backward, so slowly, so what are the divisions are going to hide or releasing from the circular scale?
Releasing and then after hiding.
After hiding again, why hiding? Okay, so if we are rotating in the clockwise direction, so in this case, why this is called as negative error? Okay, so this one is we are starting before starting experiment. We have negative error is present. And why this is called as negative error? In this case, see clearly, before rotating the circular scale, so here the 0 division of, okay, this 0 division of main scale already hiding behind the circular scale or not? Why? Because for example, if this 0 it has to come to this baseline, this 0 it has to come to baseline, means we have to rotate in the clockwise direction or anti-clockwise direction. This 0 it has to come to base in anti-clockwise direction. If I'm rotating in the anti-clockwise direction, it will move forward or backward?
Backward.
Backward. So if it is moving backward, so now what are the divisions are releasing from the circular scale or not? Initially they are hiding. They are hiding so below the circular scale, and when I am rotating in anti-clockwise direction, so it is moving in backward direction. When it is moving backward direction, now it is coming to this position. Okay, then it is coming to this position. In that way, what are the divisions are hiding or releasing slowly? If we are rotating in the anti-clockwise direction, circular scale is moving backwards. Now what are the divisions on the main scale? They are hiding or slowly releasing?
Releasing.
Releasing. Okay, so in this case, no experiment, it is not yet started. Not yet started, but already here 0, it is already 0 here we have. Okay, now to bring this 0, to reference line, to bring this 0 to reference line, so we have to rotate in anti-clockwise direction or clockwise direction.
So can you repeat?
To bring this 0, to bring this 0 to baseline, to bring this 0 to baseline, we have to rotate in clockwise direction or anti-clockwise direction.
In
Anti-clockwise.
In anti-clockwise direction. In anti-clockwise direction, now what are the divisions slowly they will release or not? In anti-clockwise direction, no, it will move forward or backward.
Backward.
Backward. So if it is moving backward means no, so what are the divisions are present on the main scale? Slowly they will release from the circular scale or not?
Yes, sir.
Okay, so in some questions, in spite of mentioning negative error, in some they don't mention negative error, they mention so main scale is hiding, main scale is hiding behind circular scale. So hiding behind circular scale is nothing but indirectly negative error is present. Okay, so if I'm not rotating, so for example here, it is initially like this. After rotation in anti-clockwise direction, after rotation in anti-clockwise direction, now this portion, it is come to here, this portion, it is come to this position, and it is circular scale. It is circular scale. Why? Because if we are rotating in anti-clockwise direction, it will move backwards. Now here 0 will be present here exactly. So if it is moving backward, now what is the scale, main scale? So initially the main scale is released or behind, that is hiding initially. In this portion, what is the main scale is present? This main scale initially where it is? Initially where it is? This main scale.
Released.
Okay, so initially it is behind the circular scale or not? Initially. So for example, so it is 0 centimeter of main scale, it is 1 centimeter, 0 millimeter, 1 millimeter, 2 millimeter, 3 millimeter. So all these are the main scale divisions. So initially here this 0 millimeter line is visible or not visible? Initially before rotating, this 0 centimeter line is visible or not visible? It is not visible. But after rotating in the anti-clockwise direction, it is moving backward. It is moving backward. Okay, that means slowly here these divisions are appeared. Okay, these divisions are appeared, but initially where they are behind, they are hiding position. Okay, so because of rotating in the anti-clockwise direction, it is moving backwards. If it is moving backwards, so here these divisions slowly they are releasing, but initially where they are behind the circular scale. So in the questions, in spite of mentioning negative error, so it will be given that so they are hiding behind the circular scale. So that is the meaning of negative error. So I will show you one statement, then it will be very clear. Okay, you see here. In the question, a screw gauge pitch is given 0.5 millimeter, circular scale 50 divisions. So can we find least count or not from the first statement?
Yes, sir.
Okay, so we can find least count. Then after, before starting measurement, it is found that when two jars of screw gauge are brought in contact, the 45th division coincides with baseline. 45th division. Okay, so for example here, now in this case, how to find a negative error? How to find a negative error? The same formula, n into LC, the same formula, but what is the n value? You have to explain. What is the n value? You have to explain. So how to find a negative error? Negative zero error equal to minus n into least count or x into least count. But what is the x value? What is the x value? This baseline. So here below zero, how many divisions are present? Don't take 46. Don't take 46. Okay. So below zero division. So how many number of divisions are present to coincide
4.
with baseline 4? So that is a 4 value. So don't take, so it is a 45, it is a 46, it is a 47, that is wrong. Okay, so below zero division, so which division is coinciding with a baseline? That number we have, so it is 0, 1, 2, 3, 4. So x value is 4 in that way. Okay, now see the question.
So we have to consider with respect to 0, right?
With respect to 0 of the circular scale.
Okay, sir.
From circular scale 1, 2, 3, 4. So fourth one is coinciding. Okay. So from the first statement, can we find the least count or not? From the first statement.
Yes.
Yes, sir.
Then after, in this case, this question comes under positive error or negative error. Positive error or negative error. I don't know how to explain.
Sir, negative. No?
So why negative error? Why negative error?
Because the main scale they
Sir,
say is
zero is
barely
above
visible.
the main
It is
scale.
barely visible. So barely visible means releasing or hiding.
Hiding.
Hiding means positive error or negative error. Positive error or negative error?
Negative.
Negative error. Okay, so in the question they don't mention so positive error or negative error. So this type of key points will be given. So barely visible means not visible, means a hiding case. Hiding case means negative error. So therefore I want to find out negative error. So how to find negative error? Minus x into least count. Minus what is the x value? So 45th division coincides with baseline. So x value is 45 or 5.
5.
5 into what is the least count? Can we find out least count or not?
Yes.
Okay. Therefore, then after, how to find reading? Generally, reading equal to main scale reading plus n into least
Least
count.
count.
And what is the main scale reading? Read the question. What is the main scale reading? 0.5
0.5.
millimeter. And which division is coinciding?
25th.
25th into what is the least count? We can find out from the first statement. Now it is a reading, but we want the true reading because zero error is present. So zero error is present, so we have to find a true reading. So how to find true reading? So reading, the basic formula is reading minus zero error. But here we have positive zero error or negative zero error is present.
Negative.
Negative. Okay, so this minus will be common, but depending upon positive error or negative error, the sign will come. Okay, so reading value already we can find out. Reading value already we can find out. So this minus into minus becomes plus, and this error we can find out. Is the procedure clear?
Yes,
Sir,
sir.
can you explain how we got it was negative error?
So it is going barely visible. See the zero of main scale. So before starting experiment, the zero of main scale is barely visible. So barely visible means clearly visible or a hiding case.
Hiding, sir, cannot be seen.
Hiding case means positive error or negative error. Positive or negative error. Hiding means
Negative.
negative.
So what would be given for positive error?
Okay, I will show you one question that also. See question number 5. In this case, pitch is given 0.5 millimeter. Number of divisions on the circular scale is given 100. So pitch is given, number of circular scale divisions are given. So we can find out least count. Correct? When screw gauge is fully tightened without any object. So without any object means before starting experiment. So before starting experiment, the zero of circular scale lies 3 divisions below the main scale or below the reference line, baseline. So if it is a reference line, in circular scale, what they have given, the zero of circular scale lies 3 divisions below. Got it?
So it's a positive zero error.
So it's a positive zero error. What is the meaning of positive zero error? I told you already. So zero circular division is below the baseline is the meaning of positive zero error. Okay, if above is present, negative error. So they can be in the case of negative error. So we have two type of statements. Maybe they will mention above the baseline or like something hiding case. One statement regarding hiding one also will be given in the case of negative error. But in the case of positive error, the statement will be given only like this. Okay, 3 divisions below the baseline. Got it?
So in the previous question, how did you find x?
That is given already in the question. Now 45th division coincides means totally 50 divisions. Totally 50 divisions and the 45th division is coinciding. So that means from 0, what is the division coinciding?
5. Okay.
5. Okay. I told you already in this case. Okay. So in this case, what is the x value is 46 we have to take or 4 we have to take? 4. From 0 you count. From 0 it is 1, 2, 3, 4. 4. The same logic you apply over here also. 45th division coinciding means you count from 0. From 0 to 45 means how many divisions are present. Okay, so it is 0. Then after it is a baseline. So it is a 45th division. 45th division of main scale. Then so 0. So we have 1 division, 2 division, 3 division, 4 division, 5 division. So 5. 5 is the x value. So it is 0, 1 division, 2 division, 3 division, 4 division. So 5th division is a 45.
Okay, so.
Okay. Is it clear? Screw gauge.
Yes.
Sir,
Please.
sir, I'm having a doubt. Like how to identify whether it is a positive zero error or negative. Like a bit confused in that part.
So in this case, what is the definition of positive zero error in screw gauge? What is the meaning of positive zero error in screw gauge? Zero circular scale is above the baseline or below the baseline?
In positive or negative, sir?
In positive. In
It is
positive.
below.
Below. Correct? So with respect to baseline, zero reading will be present below. So you see the last question. In the last question, what they have given? The zero of circular scale, 3 divisions below the baseline. So below the baseline means positive error or negative error?
Positive.
Positive. So this question belongs to positive error. Okay.
So, sir, in screw gauge and vernier calipers, the positive errors are opposites, right?
Correct. I got your meaning. It is correct. So generally, in vernier calipers, if right side is present, positive zero error in vernier calipers. Okay. If right side is present, positive error. Left side is present, negative error. But here below the reference,
It is positive.
positive, and above the reference is negative. Okay,
Yes,
so
got it.
we can keep in that way also, exactly opposite. Okay, in screw gauge and vernier calipers. Any more doubts?
Sir, can I give your number?
Homework I will share in the group. Okay.
Sir, no, for that I need to message him.
Regarding what?
Sir, that link, EMS.
EMS I will share it. Okay, so you please text me. So here, this is my number. I think in the break time someone sent me message also. It is my number. You please text me personally. I will send you EM Waves link. Okay.
Yes, sir.
So the PDF I will send you within half an hour. Okay, regarding plus PDF. Okay, I will share within half an hour. Okay.
So can we leave?
I have one more lecture. Okay, bye then. Okay. So is it clear now? So is it clear now all the points today what we had done regarding experimental skills? Then after.
Yes, sir.
Okay. Yeah. Bye.
Bye, sir. Thank you.
Yeah. Bye. Thank you.
Sir,
Bye, sir. Thank you.
Please.
sir, so will you be taking a crash course for the remaining topics like semiconductors and those?
Semiconductors, I think so. Someone is saying that there is no transistor in the syllabus. Okay. Leaving transistor. Now I will send you the questions based upon p-n junction diode. Okay, so I will send you p-n junction diode questions with the solutions. You please go through them. If you have any doubts, let me know. I will discuss in the next lecture. Okay.
Okay, sir.
So why? Because you have some basic idea, basic knowledge about p-n junction diode, forward bias, reverse bias. You know those basic points. Okay. I will share in the group. You please go through it. If you have any doubt, let me know in the next lecture. I will do it. Okay.
Okay, sir.
Yeah. Bye.
Thank you, sir.
Yeah. Thank you. Bye.